everybody, wherever you are sitting. Welcome. I hope you're all happy and healthy this morning. Phoebe's kind of told you who I am, which dismisses the first slide for me. Some of you, I've not necessarily been watching the names rolling in on the screen as you've been joining, but some of you I recognize from either the previous webinar that I did, the previous sprints that I did, whenever that was about a month ago. And some of you, in fact, I probably know from the training center at Y Boston. So I am, as Phoebe said, one of the senior instructors at Firebrand. I'm one of the permanent instructors, in fact, with them. And I've been with the team now for nearly 6 years, in fact. So prior to that, I was a freelance training consultant, ideally kind of working across a lot of different areas, I suppose, really. And prior to that, from 2007 backwards, in fact, I was in the RAF. So I come from a sort of a background, I suppose, really of security, but in the form of military intelligence, that kind of background. I did 3 years, in fact, as a secondment out as an analyst working across a whole different load of security services, but looking at sort of a counterterrorism being the main thrust of that, which kind of put me, I suppose, really in the pole position, I suppose, really, when I left the military in 2007 to start stepping up into the proper world of security, I suppose. I was lucky that I spent a couple of years, in fact, with Microsoft at the Microsoft Academy. So that was my chosen career path, I suppose, on leaving the military. Became an MCT with them, so a certified trainer, but really started to kind of go off more into the world of network security, defense, and indeed sort of more down the road, I suppose, really becoming an ethical hacker and the penetration testing route, really. But now for Firebrand, as Phoebe has said, really my main thrust, I suppose, really is looking after a couple of different strands, in fact. So I am the project lead for our cybercrime portfolio. That includes the whole range of pursue, protect, prevent strategies that some of you will be more familiar with than I am. And indeed, I also look after the open source courses that we do in-house as well. But really my sort of mainstay, I suppose, really away from some of that is the fact that I look after the cybersecurity apprenticeships as well. So from the pretty much across the gamut of that as well, which is all sponsored by BCS. And indeed, that's kind of where the future is going for me, although I will be keeping a hand on the cybercrime stuff as we go forward into the new year. I am also very much into the EC Council side of things, but for today, effectively, what I'm going to do is kind of train it back a little bit. Really, it doesn't really matter about the different vendors from the training provider point of view, because we're going to start at sort of the ground and work up, I suppose. This little course then that we put together is primarily bound for the non-technical. So when I kind of put it together, for those of you that have either seen me in action before or heard me speak, will know that I love analogies. So one of my sort of best training moments, I suppose, really, is when I'm telling kind of wild stories. And sometimes that kind of sticks for people. So what I've tried to do in these little sessions is bring some of those stories that I tell, some of the analogy together, which kind of work, I suppose, really at grassroots level. So I'm assuming no prior knowledge, which is why I've kind of said here that this is not going to be too technical, and there are no prerequisites really required for this. So if you're kind of, even if you're brand new to IT, perfect. Okay, stay with me. However, I'll flip that over into the fact that I probably will appreciate the fact that a lot of you are gifted individuals in whichever field that you are playing in, hopefully within the world of IT security. It could be to do with physical security. It could be to do with information security or cybersecurity. It doesn't make any difference for this show. This is where we're going to meld it together a little bit and just sort of underpin it. And so what we're going to discuss here is kind of go back to some basics, I suppose, really, when we're talking about what's a computer, what's a network, what does that actually mean to us? And again, I'm going to try and cram in as many of these analogies as I possibly can. Now, I kind of love these because even if you are very senior in your roles, sometimes lights go on when somebody explains something to you in a kind of a wacky way that you've never had it explained before. Those of you that are policymakers as well. So if you are involved in creating security policies, and one of my favorite ones is a user training and awareness program or policy. And if you're part of a protect or defense team on a network, then by all means kind of steal some of this and see where you can fit it in to those kind of user training programs that you may have in place. Because what I've generally found is that without kind of dumbing it down to the fact that, you know, users have intelligence and they are generally kind of gifted individuals, if you can make something relevant to them by telling them a story or putting it into words, I suppose, really into descriptors that everybody can understand, it really works. And what we try to avoid, in fact, and what I generally love to do, and especially if I've got any of my apprentices on this call, you'll know that I love technical jargon just like everybody else, and I love ones and zeros, and I love the technical side and I suppose the higher level of what we do. But I also love the way that people can translate that down and turn that into a form of words, which you can either put before your end users and or indeed to the management team. And for those of you that are into law enforcement side of things as well, sometimes this is important as well if you can get this across as being part of a witness team, for example, if you're getting across to judge and jury as well, and how to explain things and get things into a form of words. Now, I'm kind of saying this with a bit of a smile on my face because what you'll see today, in fact, is going to be possibly the worst PowerPoint slide that you've ever come across in your entire life. So if you want to steal it, by all means, use it. And I'm going to caveat this with the fact that normally, under normal circumstances, what I would do, of course, in a classroom environment is kind of build up and draw pictures and things like that. And again, once again, those of you that kind of know my delivery method, it's very rarely that I'm actually kind of sat down, I suppose, really, and very rare would I actually be just clicking next through a whole load of PowerPoint slides. But what I've done is I've kind of put this build slide together, which invariably would be a whole load of stuff that I would generally discuss with the audience and put together on whiteboards, and we'd kind of have some fun with it. So hopefully we're going to make this fun as we go through, but there is obviously a serious point to all of this. Okay, so when we're sort of layering in all of these different ways that networks are formed and how devices communicate and so on and so forth, we're also going to get towards the end. So the third session that we'll deal with, we'll start to sort of geek you up a little bit, and we'll get a little bit more technical, I suppose, as we bounce through. And you'll see, hopefully, that I've kind of layered that in a little bit. Now, what this is useful for, I'll just take a slurp of water, excuse me. What this is useful for is pretty much anything. Okay, so again, away from the different types of courses that you may be undertaking or you may be considering undertaking, all of this really cuts across, really. And as I've said at the start, what I'm trying to do here is kind of merge cybersecurity, networking security, and InfoSec all into one. So it doesn't really matter which bundle, which package, which kind of label you want to give yourself here. Hopefully this will fit in very nicely for you. And as I mentioned, particularly useful, hopefully you'll agree at the end of it, for any kind of user training and awareness programs, or if you're involved within a protect team, for example, there might be some nice little sound bites that you can take away from this. So that's kind of how I've done this. As Phoebe has said, feel free, throw your comments in at Phoebe. Luckily, she's moderating everything. So if you're going to be rude, she'll filter that and I won't get to see it. Yeah, for those of you that know me offline as well, you can be rude to me offline as well. Feel free to use any conduit you want to get your comments and questions back to me. And again, even after the course, become a friend of mine and find me on LinkedIn or any other channel. Use my email address and send me any questions or comments that you may have. So without much further ado, let's kick off with, I suppose, analogy number one. Now, again, cutting to the chase a little bit, it's lovely when we're starting to talk about computer systems as well. Well, I normally break these down into body parts. So what does a CPU do? Well, that acts like a brain fill, that kind of thing. What's a RAM? Well, that's part of your memory, which is associated with your brain, and all this kind of great stuff. While we're talking about networking then, let's think about ourselves and how do we, as human beings, actually physically communicate? So to start off with, what kind of ways do we communicate? It means of communication. So you can speak. So verbal communication. And then, of course, we've got different ways of communicating with non-verbal. So without using speech, in fact, And so this could be either through using signs or signals. It could be just by using body language, or semiotics is what we call that for those of us that look at forensic linguistics and things like that. So the way that somebody says something may actually mean two different things. It may be the same word, but the way that you say it, you may be a little bit more forceful, or you may be a little bit more laid back, will actually have meaning in the way that you verbally communicate things. And of course, away from using effectively body parts to do this, you can also write something down and you can send it. So you can send a letter, for those of us that are old enough to remember how to write a letter without using these new fandangled email systems. What do you physically use to do that? Well, in order to communicate, you must have some kind of physical apparatus, if you like, or physical part to you that allows you to do this. Okay, so again, if we're talking about body parts here, you can see, you know, for verbal communications, you'd obviously be using your mouth. He says with a big smile on his face, because some people can talk out of other orifices. That's probably true, but we'll hold that for a different course. You use your eyes to communicate as well. So you can wink at somebody, for example, or you could stare them out. And of course, you use your ears to receive the communication. So your mouth, your eyes, and your ears are all three different parts of your body, if you like, that you have that allows you to physically communicate. And indeed also your hands, of course, you can wave at people, stick your thumb up and all that kind of thing. And then if you want to go down into the written side of things, of course, you'd need a pen and a paper. If you were then going to communicate, you would need labels. Okay, so you would need a name. Okay, so and invariably here we get named, obviously when we are born or when we come into a family, or however, whatever naming convention you have. As soon as you join, let's say, a network of friends, you're given a name. Now that might be the name that you're given at birth. It may be a nickname. So some of us have multiple names, but they all are akin to the same person. So, and again, my name is Philip. So I'm generally only called Philip when I'm in trouble, and most people refer to me as Phil. So I've effectively got two names that I answer to. And when it comes to where I live, okay, then you have a physical address. And once again, you'll find that you've got multiple addresses. So if you think, possibly not at this moment in time, because hopefully the majority of us, where we possibly can, are working from home, but you'll have home addresses and you'll have a work address. And the sad fact is, of course, that you probably spend most of your waking moments at work, at your work address, and most of your good times at your home address, or wherever it is that you like to hang out. So you will invariably also have multiple addresses for the same entity. Now, address here is obviously a location. Okay, and so if you are communicating to somebody, you would need to know their name and their address. Where do they live, and what are they called? And so this kind of makes sense, doesn't it? The way that we communicate also is important to us. So you can think. So you can loop back. And a lot of us think before we speak, hopefully. So you may, a lot of us don't, of course, but a lot of us will go through this process pretty much quite routinely of actually talking to yourself. You'll be surprised when you sat there on the bus, or you're waiting for the bus or the train or whatever it is you're doing. You're kind of thinking, mulling things over, aren't you? You can, of course, talk to yourself as well, which they tell me is the first sign of madness, but it happens, doesn't it? Occasionally you may find yourself, hopefully with not too many people around, and you're just chatting to yourself quite nicely. And why not? Okay, why not? The other way that you can communicate is you can speak to everybody. So like I am at this moment in time now broadcasting out. I've now thought of what it is I'm going to say. So I've kind of looped back, if you like. And now I'm broadcasting out to everybody that's on this call that can hear me, but not anybody in particular. Okay. The other way that I could do that is that I could pick somebody in particular. So if I wanted to communicate with Anton, for example, because he's the first one in my list, I could then have a one-to-one conversation. Okay, let's call that a unicast arrangement between Phil and Anton. And we could then share information and we could have a little chat. Okay, the other way that I could do that is I could select 3 or 4 of you together and I could put you into a little group. And so I could then start talking to 3 or 4 people all at the same time, but not addressing everybody that's on the call. Okay, and this is a way of choosing multi-people, if you like, or let's call that multicasting. Why not? Okay, and I can also communicate at different areas. So what we have is a physical connection together. So not only the people that can hear me, but the people that are local to me. These are the people that are in my local area, if you like. And if need be, I can also move from my local area and go off onto a wide area. So invariably, if I write a letter, the reason why I'm writing a letter or sending an email is because the person is not sitting next to me. If the person is sitting next to me, I'll turn around and I'll chat to them because they're on my local network. If I need to then communicate further, going from my local network to a wide area network, let's call it that for want of a better term, then that's exactly what I'll do. And what I'll use are different systems to do that and different procedures and policies and things like that. What has come together, by and large, is an internationally agreed set of standards that allows us to do this. So if you're writing a letter, you know that you've got to put you've got to put it in an envelope, you've got to put a stamp on it, you've got to put an address on it, and in order to send it, and you know how to send it. So there's an internationally agreed standard, and it doesn't really matter where you are on the planet. That kind of works. Okay, we could take this back a step as well. So when we're talking about verbal communications as well, the different protocols that we have in place there. Now, again, this is where potentially this analogy falls foul a little bit. And I know this from first-hand experience, is that invariably for those of you that are in my close circle of friends, I'm a big kind of touchy-feely kind of dude. I'd rather give you a hug and shake your hand than kind of be standoffish with you. Obviously, these days, let's not do that for the time being, but I cannot wait until the government give me green light to start hugging folk. Now, you might be running scared. The good news is that I live in France. So for all of you that are in the UK, don't worry, Phil's not allowed on the streets anymore. And there is a set of protocols, isn't there? So when people shake hands, for example, and there's a joke here somewhere, gentlemen do it standing up, ladies do it sitting down, and dogs do it on 3 legs. There is another joke there somewhere, but I'm not going to tell you that one. But there are protocols that are in place in how we actually then shake hands, for example. Now, again, this is where potentially sometimes this doesn't necessarily fit across international standards, because you can do something with a verbal communication or hand signal in one part of the world, which means something completely different in another part of the world. And you can get that horribly wrong, of course. Okay, so thumbs up and thumbs down and winking and blinking and all that kind of stuff. Kissing people in France is a kind of a agreed, accepted normal way of meeting each other. If I was to walk up and down the streets of London and kissing everybody on the cheeks 3 or 4 times, then I'd probably be locked up within 5 minutes, and probably rightly so, to be honest with you. I'll probably be locked up anyway, regardless of that. But you get my point. So even though we have got a whole load of agreed international standards, sometimes they don't translate from one network to another network. So what we have to do is we have to translate these different standards to make sure that we're using the right kind of protocols for the network that we sit on. So with all of these different means of communications, we also have ways that we can move across international boundaries in order to communicate. Okay, so this is, if you like, analogy number 1. And now let's put that into compute speak, if you will. It's very difficult. If you were to sort of think long and hard about what actually is a computer, it's difficult to define that. And again, it kind of makes me smile sometimes when we look at things like the Computer Misuse Act and things within the UK, where it doesn't necessarily define what a computer is. Well, I don't have an issue with that personally, because it is very, very difficult to actually come up with a definition of what is a computer object. Okay, but it's got to have a processor, it's got to have some kind of memory, it's got to have some kind of storage. So those 3 things come together. But this could be your smartwatch, it could be your calculator, it could be your laptop, it could be your fridge these days. Okay, they're all computer devices. The nice thing is, though, when we're defining a network, that's easy, okay, because a network are 2 or more of these devices which are connected together in order to communicate or share data. That's the kind of dictionary definition, if you like, of what a network is. So when I've got 2 of these things that are communicating, or 2 or more of these things that are communicating, I now have a network. Now, in order to do this, the computer itself must have these 3 things. So it must, just like you, must have a network interface. So it's got to have a mouth. It's got to have a physical part of it that allows it to send and receive. So physically send and transmit stuff, okay? And that will come in the form of a network interface card, for example, okay, a network adapter. It must also know who it is and where it lives. So it must have a network identifier. So it's got to have a name and an address. Okay, and as we've mentioned here, it may have multiple names, and it invariably will have multiple addresses. And it must also know, as part of its DNA, if you will, the different networking protocols. So how do I actually nicely communicate either within my local network or out there on a wider network? Okay, and then how do I send and transmit this stuff as well? So how does that physically happen? And when is it good to wink at someone, and when is it good not to wink at someone? And how do I translate that if I need to? Okay, so if I want to convey that particular message onto a different network to a different person, do I have to translate it? So this is where we could potentially think about different languages that we use globally as well. So when is it good to speak English? When is it good to speak French? When is it good to speak German? When is it good to speak Dutch? And so on and so forth. Okay, and what we don't automatically assume is that everybody speaks English. That's your typical British person on holiday with knotted hanky on head, Union Jack shorts, and eating fish and chips in Spain. Perfect. Okay, all they do is stick an O on the end of an English word and expect that to be Spanish, which to my Spanish friends out there is not quite how Spanish, I believe, works. Okay, and so what we have to do is have mechanisms that allow us to translate this properly, okay, in order to communicate across different networks. From a compute side of things, then, we're talking about a network interface card. Okay, and without being too technical about this, I suppose, really, it's obvious, hopefully, that this is an essential component. If you want to communicate on your machine, you can have a processor, you can have a hard drive, you can have memory, but if you need to communicate shared data, then you must have a network interface card. Now, these are multiple, so they could be something that you stick a wire into. These days, of course, it could be wireless, or it could be a Bluetooth device, or it could also use light. So we could also have fiber optic in play here as well. And that's what we call the media, or the medium that it's putting onto. And it's not unusual or uncommon, of course, to find devices that can do multiple ways of communicating. I invariably would know definitely that you will have plenty of people on this call that have a device, so a laptop, for example, or a smartphone that is able to do Wi-Fi, so it can use a wireless network adapter, it can use a wired network adapter, and indeed it may also use Bluetooth, which means that it's got multiple ways of communicating. It also means it's got multiple addresses as well, because each one of those network appliances or the network adapters has got its own physical address. That's what we call its media access control, or its MAC address. And this is also referred to as the physical address of the computer. Okay, that kind of stays with the device, remember. So even though it's not the computer itself that it's referring to, it's that component part, if you like. In most cases, the network adapter stays with the physical computer. Of course, you can swap them out, you can change them. You can also do something called spoofing a MAC address as well. So I can actually change it from the manufacturer's applied name, if you will, and I could change that so that it reflects something that I want it to be as well. So spoofing, when we're talking about spoofing in the terms of communications, networking, and indeed computers generally, we're talking about networking. So we're talking about spoofing IP addresses, for example, or spoofing MAC addresses. That's simply changing it for one purpose or another. It doesn't necessarily have to be nefarious reasons to spoof a MAC address, however, but they are used for the wrong intent as well. The other types of network identifiers that we have to contend with then, a host name. So that's the friendly name of the computer, just like my host name, if you like, for me, my friendly name is Phil or Philip. So that's generally given to me by the administrator. So it's given to me by my parents or the orphanage or whatever your backstory is. And so there I now know that my name is Phil Chapman. So I am Phil and I'm part of the Chapman family, if you like. I'm part of the Chapman network. And so I know where I sit within that. Now on Saturday, just like everybody else on the planet, France is in total lockdown now as well, by the way. That's started today. So of course we're not going out, but we'll have a Zoom meeting with the family. And so I will meet up with other members of the Chapman clan, albeit online. But if we were all back in the UK, of course, as long as there were 6 of us maximum, we'd all meet up in the same place and we could then all chat to each other, and we all know each other by our common name or by our friendly name. Now, from a computer point of view, that's a very old way of communicating. If it was a Windows machine, we would refer to this as a net BIOS name. But those kind of systems these days are very, very rare. In fact, you won't come across it, okay? But it's still part of your DNA, or the computer's DNA, if you like, to be able to communicate one-to-one by using hostname to hostname. What it prefers to do is use a nice international standard to do this, which is the Internet Protocol, or IP. Now, IP breaks us down effectively into a postcode and a house number. And it's the best way, if I'm talking about IP version 4 and IP version 6, essentially, in thinking about what an IP address is. Postcode and a house number. And if you think about it, it doesn't really matter where you are on the planet. You will have a zip code, or over here in Europe, we use a slightly different system, which is very, very much like the American way of using numbering, in fact. So not quite as complex as the UK system for postcodes, I have to say. But over here, we will use, in my case, we're using 5 digits for the postcode, and then your house name or the number will then be tagged on the front of it. Back in the UK, you use a series of letters and numbers, for example, in order to do that. And some people can discern exactly where that is. I'll come back to talk about that in a little bit, but that's a great way of thinking about what an IP address actually is. So let's put that into another one of Phil's analogies. And here is one that you might have seen before, because this is a local area network. So here we are sitting on a street, a road, which just so happens to be called Firebrand Way. Firebrand Way applies to every single house on this network. So that's the network address. Bob, here we go, good old Bob and Alice. There's a reason, probably, I don't know why it always is, but you notice on these analogies that Bob and Alice are never together. There's probably a backstory here, but Alice has decided that she's now not going to live next door to Bob. She's a couple of doors away from him. Probably, again, a different story. But Bob's house is the friendly name. Bob knows that he lives in Bob's house. And Bob also knows Alice's house, and Alice knows Bob's house by friendly name. So they know where each other lives by using the host names of the 2 buildings on Firebrand Way. However, in order to communicate here, what if Bob was going to go to Alice's house, for example, he would need to know where her front door is. So that's the way that he's going to go into Alice's house or speak to Alice, by knocking on the door and communicating to her, okay, on Firebrand Way. In order to do this, then, he needs to be able to locate Alice on this local area network. Okay, so what he does is that he needs to know that Alice lives at number 4. Bob lives at number 1, so that's the host ID. So he is number 1, Firebrand Way, and Alice is number 4, Firebrand Way. That doesn't describe, however, where Alice's front door is. And so what Bob has got to do, he's got to translate number 4 Firebrand Way into Alice's house and Alice's front door. And he uses a series of protocols to do that. It's a very rudimentary protocol, admittedly, that he uses on this network, because ultimately what he's going to do is he's going to stand outside of his house and he's going to shout down the street for Alice's house, number 4, where are you? Once Alice's house receives that request, it then identifies itself to Bob, or Bob's house, and Bob now knows where Alice's lives. Now, the good news is that Bob can remember stuff. He's got some memory, so he will cache the location of Alice's house, so he doesn't need to shout for Alice. And the next time that he wants to go and communicate with Alice and find Alice's front door, he will remember where she is, and he will go nice and quietly to her front door without putting all of that noise and clutter, so that number 2 and number 3 and anybody else who can listen in on this local area network can also hear that. Okay with that. And this is the way, this is a series of protocols that are coming into place at how Bob would find his way from his house, number 1, to Alice's house at number 4. Happy with that. Now I'm going to put the technical side of this into place, don't worry, but some of you are probably already screaming at your screens here that this is using something called an address resolution protocol, changing different addresses invariably from number 1 to Alice's door, or number 4, I beg your pardon, to Alice's door. Another protocol that we need to contend with here, which is a quite serious protocol, of course, is IP. Now, I've already said that this is just like a postcode and a house number. So here you can see on the slide, I've got a couple of examples here. I no longer live in the UK, but this is roughly where I used to live before we moved out here to France. So HD15BP, you can see in the bottom left of the slide here, is a postcode. And you can see that the number on the end, 10, that's a 10. So that's in decimal, is the postcode and the house number. Now, if you were to just look at that, and if I was to ask you the question, what's the postcode and what's the house number? If I hadn't made the house number red, for example, you would be guessing at where the postcode stops and where the house number starts. And so in order to make this absolutely crystal clear to the postal delivery system, to the post office, what we do is that we put a decimal, a binary 1 underneath everything that's a postcode and a binary 0 under everything that is a house number or the host identifier. And so in this case, it is absolutely an accurate way of saying that this is HD15BP is the postcode and 10 or 10 is the house number. And so with this postcode and house number, and let's call it a subnet mask in arrangement here, the postal delivery system and you also know that this is not going to be on your local network. And so this now needs to go into the post box at the end of your street. So you put a stamp on it and you take it to your default post box and you can post it away. And then what happens is, do you know what, Phil? Magic. Because somehow that letter goes from your local post box to the recipient's door. Isn't that crazy how that works? Okay. And so here we're talking about a whole different series of protocols working at all different kinds of layers in this process in order to deliver your letter nice and safely. Now, if we look at that from the world of IP, and here's an example of IP version 4, you can see that we've got 192.168.2.10. And again, if I hadn't color coded these and asked you the question, where's the host identifier and where's the subnet here? Some of you smart arses will be saying, actually, Phil, I know where the host ID is and where the subnet is on this one, because I recognize that as being a class 4 IP version 4 address. Well done. Okay, that means that you've done a great Network Plus course or a Security Plus course with firebrandtraining.com. And you know exactly how these ranges work. However, I would then counter this with the fact that, well, actually, this is an internal IP address and it could be anything. So even though, yes, you are probably correct, it's what we call an educated guess, okay? And it would be an educated guess rather than an accurate description of what this IP address actually means. Without the subnet mask to actually verify the fact that you are correct. And so here you can see the subnet mask of 255.255.255.0, which is written in decimal notation. So base 10. If I was to get all geeky and freaky on you and turn that into ones and zeros, that would be 24 ones and 8 zeros underneath that number. Again, don't worry too much about that. But that's the way that your IT system, which only speaks in ones and zeros, remember, is able then to delineate between the subnet, the street address, if you will, and the host identifier, the house number. Okay, and that's how IP version 4 breaks down very nicely. Okay, and for those of you that come onto my courses will know that I'm particularly anal about the fact if you're going to give me an IP address, okay, as an answer to a question, and you don't give me the subnet mask, it means nothing. Okay, so you must make sure that you get both of those together. It's like apple pie and custard. You can't have one without the other. Okay, so subnets and subnet masks go together. To kind of round all of that up very quickly, okay, this is what we're talking about. So things are internal and external. So I can have a private internal IP system and I can have a public external system, just like you can have an internal mail system that allows you to send letters or send messages internally on your own systems. You will use your own letters and number systems to get things from the HR department to accounts and from accounts to marketing and so on and so forth. Okay, and nobody really needs to know what's happening on the inside of your network. As soon as you want to send something externally, however, there's a public system that does that. And this is when we're then talking about the post office system. You cannot make that up. That's set in stone because it uses a public mailing system. So you must use internationally recognized or nationally recognized postcodes and house numbers. Okay, you can't make that up. And so what you have is a system that translates from your internal network to the external network. And this is called network address translation. And most of us are probably using NAT or a form of NAT, which is port address translation on our internal networks to get us from an internal IP range to an external public range going out onto the internet, for example. And this is done through a device, which we lovingly refer to as a router. Okay, and we lovingly also refer to that as our default gateway. Think of that as the post box at the end of your street where you always go to post letters when you can't hand deliver stuff. That's your default gateway off of your local area network to your wide area network. And all of that is then controlled out on the internet by using a series of ISPs, which are all connected together that share this data from one place to another. IP version 6, which is the new boy on the block, if you will, that's coming to us soon. Well, most of us, in fact, are already using IP version 6, and a lot of us don't even know that it's happening. In fact, IP version 6 doesn't use network address translation, doesn't need to, because it can pass directly through from your appliances on the inside of your network to the outside network, okay, by using a temporary IP version 6 address, which is all controlled by your ISPs. Now, IP version 6 has got its own built-in security mechanisms to do this as well. So don't think that the floodgates have opened with IP version 6, because it's a nice, safe, secure, efficient way of doing stuff. It will eventually take over from IP version 4, but that's not going to be anytime soon. So we don't really need to worry too much about that at the moment. To put that into a nice little picture, that's kind of what it looks like. And again, what I've done here is I've just taken a quick screenshot from my local router here on my local network here. Again, I apologize to you if you can see that, if you can read it, which hopefully you can, because my router is French. I live in France, so Orange France have given me a network appliance. And what I've done is I've clicked on the button that says, don't speak French, speak English. And it's translated some of the words are misspelt. And it hasn't necessarily used very good English, but its English is better than my French, I have to say. So here you can see on the network address translation, port address translation settings that I have on my local device here, which is downstairs in the living room, is the NAT and PAT settings in here. And it tells me here that this is only for IP version 4 equipment, which is bang on. It certainly is. Okay, and this is a way also of layering a bit of security, if you like, because it also then hides what's happening on the inside of my network. The protocols themselves, the way that we do things, have been born from the fact that all of these different computer devices, okay, so imagine now the situation where you've got your fridge that can speak to your router, and your phones that can speak to your Alexa, and your laptop that can speak to your network appliances. All of these devices are built and manufactured by different companies, different versions and different operating systems and so on and so forth. It would be a complete mess if they all use different protocols and different languages in order to communicate. So way back, that was how the world spun. Okay, I'm now talking kind of almost prehistoric times, admittedly. So we had things like Apple devices which used Apple Talk. We had Microsoft that used NetBIOS, and trying to get them to communicate was like oil and water. Okay, it was they could eventually do it, but invariably it was very clunky. And so years ago, the powers that be came up with this system, which is called the Open Systems Interconnection Model. And all this is a 7-layer framework that allows us to see at different levels what protocols are used in this thing called networking. Now, it's a bit clunky, the OSI, admittedly. And for those of you that have done any kind of networking courses will know, oh, here we go. He's going to get us to learn these. Well, if you are learning it for an exam, perfect. Okay, that's not what we're talking about here today. What we're going to do is we're going to put this into exactly what it means. Okay, so rather than just learning a whole load of lists and numbers and things like that, which probably don't mean a great deal to you, let's put it into context and see how it actually works. And how it doesn't work is like a conveyor belt of stuff. Okay, so layer 7 doesn't hand off to layer 6, doesn't hand off to layer 4, and so on and so forth. We'll see how it all fits together once we've had a cup of tea. Okay, so again, get ready for the analogy of your life, I have to say. So when it comes to how a modern network rolls, what we generally do now is, rather than use the OSI reference model, which is, as I said, this is 7-layer approach in here, we've broken it down into something called the Department of Defense, or the TCP/IP model, which breaks it effectively down into 4 chunks. Okay, it still refers back to the 7 layers of the OSI. That's very true. Okay, and those layers are important to you if you're going to be a network engineer or a developer, or if that's where you're going in life, or that indeed that's where you are at in life. Brilliant. Make sure that you know the OSI. There's a reason for it. It's not for this course, okay, not for this discussion that we're having. But if you know it, fantastic. Okay. The TCP/IP, as you can see, then breaks it down into 4. And what I've done here is effectively broken those 4 bits down into the useful parts, I suppose. So the application layer, the transport layer, the internet layer, and the network access layer. And again, you can see from the slide exactly what those do for us. Okay, so the different levels. Now, again, it says up here, networking OSI TCP IP just for reference. You know that as soon as an instructor says just for reference, and the old question, Phil, is this in the test? You instantly turn off. And so you can instantly turn off on this because I'm not right bothered. Okay. When we start talking about layer 7, layer 4, layer 3, layer 2, and all that kind of stuff, that's for another day for us, because this little session that we're having here is about what the heck does that mean to me in my job capacity, in my role, and how could I actually relay this into useful information? That's what I'm going to try and hopefully get across to you in this session this morning. Okay, so well, even though personally I am bothered, okay, and I'm hoping that it will ignite your passion to go to run away and learn the OSI reference models and the TCP IP and how that all fits together. That's another day for us. In order to do this, now again I apologize to you because some of you may have seen Phil do this before. If you've been on one of my networking courses and one of the foundation courses, I may have done this with you before. Okay, but I'm going to layer it in anyway. And I believe that some of you may also work for network rail or railway systems as well. So you're going to be good at this. Okay, so if you can think about how to build a railway, you're going to do all right with the OSI. Okay, let's think about, before we have a cup of tea, what is a railway system? So you can see here that a railway network allows for connections between local to local and local to wide area. So if you want to go from one place to another, you're going to get on a train. So this train might be from, I don't know, it could be from Penryn to Falmouth, okay, which isn't going very far. In fact, you can smell Falmouth from Penryn, or you can smell Penryn from Falmouth, whichever way around it is, whichever way the wind's blowing. You can see these two places together, so you don't necessarily need to get on a train to get there. But in this analogy, you would use a local train in order to do so. If you wanted to go, however, from Falmouth to Glasgow, then not only are you using a local railway system to get to, I don't know, Exeter or wherever the big railway system is, Truro perhaps, you then need to go further. So you're going to use a series of different internetworks that are going to connect you from a local area to a wide area network. So if you're going from, I don't know, a little village in Somerset, you need to go to Bristol Temple Meads to get to London, for example. So you'll go from a small network, a local network, to a wide area network using this railway system. And that's what a railway network allows you to do. It all allows you, not just for people, remember, so all kinds of stuff is transported on railway networks, I've noticed. And if I've got any train spotters out there, actually, if I do have any train spotters out there, just leave now. No, stay with me, because you might be able to put some technical bits in place here as well. These are those hobbyists that stand at the end of railway platforms. You see them with their duffel coats on and their notebooks and flasks and things like that, and they're watching trains coming in and out and writing down the numbers. Lovely, I'm all for that. But what they will notice is that sometimes you've got passengers, sometimes you've got livestock rolling out, sometimes they've got all kinds of different low loaders with mechanical devices on, and sometimes as well you get, invariably you won't see these at railway stations, you get things like spent nuclear fuel rods and hazardous materials and things like that. But all of this stuff can be transported using the right type of wagon or the right type of train from one place to another. So it's not just about passengers, okay? All kinds of stuff can be transported on a railway network. It uses a whole series of different laws, regulations, and standards. So not just anybody can set up a railway network. God knows how long has it taken HS2 to come to fruition, okay? And invariably what we're looking at there, of course, is getting over a whole hurdle of regulations, laws, standards, and practices, and so on and so forth. So these have to be very, very closely adhered to. It has to be fairly well managed and, of course, engineered. So we have dedicated people that look at the management side of this as well as the engineering side of things. And it's quite a complex set of technologies that come together to make this happen. It's got to be well monitored in all different kinds of levels. And again, if you've seen some of those kind of fly in the wall documentaries, you'll know that there are big panels that look at the way that the trains are running to make sure that they don't hit each other and the signals are working. And that indeed, we also could then be monitoring who's on the platform, for example, and who's anywhere near the tracks and all that kind of stuff. So a railway network, the whole system itself is monitored in different ways. And that's to maintain, of course, the security side of things and to make sure that it's available. it's got to be updated and upgraded. So on Monday morning, when you go to Bristol Temple Meads and you say, the train's delayed because of overrunning engineering works, that's because they've updated it on a quiet part of the day. So they tried to do it on Sunday afternoon, hit a snag, and of course that's now had a direct impact on Monday morning commuters. That kind of happens, doesn't it? Okay, well, that does happen. And so the network has to be updated and upgraded. And again, regular, what does that mean? Doesn't mean it's every day, but it could be once a week, once a month, once a year, once every 6 months, depending upon what your maintenance schedule is. It's got to be kept safe and secure. And that's what we're here today to learn all about. And notice here, I put this in brackets, as best as possible, because nothing, my friends, is 100% secure in any walk of life. Okay, you can never have 100% security. Okay, as much you can throw as much tech at it, as much money at it, as much expertise at it, you will never be 100% secure. And a railway network, as I've mentioned, is a complicated set of technologies that all fit together, okay? And you don't necessarily have one person that knows absolutely every single nut and bolt that comes together. You will have experts dotted around this system who are subject matter experts and experts in security, experts in engineering, experts in electronics, drivers who are experts obviously in their field. And so it comes together to build this thing called a railway system. And now if you just do me the honor of removing the word railway from that slide. And that just leaves you with the word network. And so everything that we're dealing with here on a railway system is also applies to this thing called a network from the world of IT. What we're going to do now then, we're going to, I think I've run over by about 5 minutes or so I beg your pardon. So we're going to take 10 minutes, I think, to have a quick cup of tea. So do that. What I'd also like you to do is just have a think, because when we're going to come back, I'm going to hypothetically ask you the questions and then answer them myself. But have a think about the different basic elements that come together that would make this thing called a railway network. Don't think about the high-tech stuff. I'm not bothered by all of that. So if you are a train spotter, brilliant. Okay. By all means, send Phoebe all of those great things, because I think she's a train spotter secretly. So she'd love to get all your comments about the way that railways actually work. That might not be true, but there you go. So concentrate on those. Have a great cup of tea, and we'll see you back at 10 minutes. Phoebe, am I passing over to you or?
No, stay as is. So I'm going to pause the recording now, and then if we're back by 11:05.
Perfect.
Yeah, great. Perfect. Okay, see you then.
Perfect. Thanks, Phoebe, and welcome back, everybody. Hopefully you're suitably refreshed. For those of you that remember me, I was in the RAF, and so having like 2 tea breaks in 3 hours is almost a travesty. It should at least be about 30 tea breaks in 3 hours. So you can blame Phoebe for that. I was dead against it. It's a travesty, it's what it is. But welcome back anyway. So building on from our networking and our railway analogy, this is where we're going to go with this. Okay, so hopefully you spent your tea break thinking about probably what the heck is he talking about, but hopefully thinking about the different component parts that come together to make this thing called a railway network. Now, normally what would happen is that we'd have this as a around the kind of classroom discussion, and I would be scribbling in sort of cartoon fashion on a whiteboard. I could do that. I do have a whiteboard with me, but I'm not particularly good at drawing. So I brought all this together down into a PowerPoint side of things. And again, I'm asking the questions, what are the component parts? And I'm going to answer them myself. Now, what I'd be interested in, however, is that if there's anything that I miss from this, or anything that's kind of in the back of your mind and you're shouting at your screens now, he's not mentioned this, he's not mentioned that, then let Phoebe know. Okay, so use the channel to let us know if there are any kind of component parts that you think are missing from this diagram as you go through. And again, once you have once I've completed this slide, you'll see that we're going to build a big picture that hopefully will start to kind of open your eyes a little bit. And for those of you that have discovered the OSI reference model or the TCP/IP models before, I'm hoping that the lights will go on fairly kind of soonish as we go through. But even though you may have some experience in this as well, you're the audience as well as the people that are new to this, in the fact that I hope this is going to make some sense to you and put it into the right kind of perspective for you. What I hate from especially if you're reading this from books and things like this, is the fact that it would always appear from the OSI side of things that it's almost like a conveyor belt of stuff that happens one after another. It really is not like that. Okay, so when we're talking about this framework here, it's almost like two big balls of energy, if you like, that we're talking about. So let's cut to the chase and start talking about building a railway network. So the first thing I'm thinking about is in order to get a railway going. So Christmas is coming. I'm secretly hoping for a train set, like every young boy on the planet is expecting a train set, perhaps. I don't think I'll put myself in that category anymore, but here it is. The first thing I'm going to do is you're going to get it out of the box and you're going to put the track together. And so what is a track? Well, a track are the physical components that allow for the whole thing to connect together. So it will invariably connect two endpoints together, which are railway stations. So if I'm going from one place, let's call that the source, and I'm going to another place, let's call that the destination, I need at least two railway stations. Now of course, a national or an international system will have multiple railway stations. And what do? Well, they allow people to come get on the train, they allow the train to stop, to go, and they also allow the trains to go in different directions as well. So a train may come in to one of these larger stations and go off in a different direction, off onto a different track. So also then, let's say, allows things to route from one place to another, okay, going through here. Sometimes the train has to stop when it gets to a railway station to let people get off, and sometimes they go straight through very quickly, okay, because it's a fast train that's going up and down the line. So it doesn't necessarily mean to say that the train, whatever that is going to stop at a railway station. It may just pass through or be routed through on one line to another line. We also then have, once you've kind of put your railway station in place and put your track down, we then have a whole load of different signals which we're going to use. So the trains need to know when to stop and to start and when they need to slow down. And there's a whole load of different protocols that are used here, different signs and signals that are used. Invariably, train drivers and engineers will know exactly what these mean. And if you're a passenger on a train, you've got no idea. You've probably got a rough idea about what red means and amber or green, because those are kind of international protocols that we use if you're a road user. So if you're a car driver, for example, you know that what red, amber, and green kind of mean. However, these protocols may be different for railway systems. Okay, and again, these protocols are also can be different on different international systems as well. So, and so the signs themselves had to be interpreted by the different component parts, by the train and by the train driver, and or indeed by the monitoring systems. But what we try to do, of course, is make these as standard as we possibly can to avoid any confusion. I live in Europe, so I live in France. I know that we've got some German friends with us. We've probably got some Dutch and Belgian friends with us here on this course. And again, I apologise if you're from further afield. Fantastic. But in the UK, when you come to a traffic light, for example, you know that it goes red, and amber, green. That's the combination. And you know that red means stop. Red and amber means get ready to stop, effectively. Amber means get ready, and then green means go. Okay, and you know that you shouldn't run an amber light. Over here in France, for example, and it's kind of confusing from a British point of view when you're driving in Europe. Red obviously means stop, but flashing amber actually means go, but go with caution. So if you're at roadworks, for example, and you see a flashing amber light, don't hang around for the green light because it's never happening. Okay, it won't work. And so you need to know what the different protocols are, what the different signs are. And again, we try to make these as international as we possibly can. The whole purpose of this system is to get a person, and in this case, I don't know, what are we going to call him? Let's call him Bob, to get him from one place to another. Excuse me. And in order for Bob and his friends to go from one place to another, what he's got to do is he's got to get into a railway carriage. Now, Bob, because he's clever, knows what type of carriage he needs to get into. He needs to get into the railway carriage, which is designed for passengers. It's got seats in it. It's got a toilet at one end. You can put your luggage down somewhere. Occasionally, somebody with a trolley comes through and gives you a sarnie or a cake or something like that. Does that still happen? Possibly not. But he gets into a carriage which is designed for the security and the safety and the comfort of passengers. Okay, now the beautiful thing with Phil's railway system as well is that when that carriage is filled up, you would need to then put the next people in to another carriage. But what could happen, of course, if I've got lots of people, is, as what indeed does happen, of course, is that we compress them all in. So we squeeze up a little bit. Anybody ever been on the London Underground when the driver said, step away from the doors and please squeeze up a little bit to make room for other passengers? Well, you're like sardines, aren't you, in there, and it gets very hot and bothered, but they've crammed as many people as they possibly can all into one carriage. That, of course, makes it quite efficient way of getting, let's call it cargo or payload, from one place to another. So if you can compress it a little bit and get it into, I don't know, what should we call this, a packet? Let's call it a packet, because that's a good term. The carriage itself means that it's now going to hold as many passengers as it possibly can, but it gets to bursting point, and it may mean, of course, that you may need to put another carriage in place. Now, if that happens on my train, then I will also then have a sequential numbering system so that I know that this is the first carriage of two. So 1 of 2, 2 of 2, and so on and so forth. If it's a large train, then I might have 10 all lined up together, all with different people obviously in. And so I now know that there's a sequential number that goes from 1 to 10. And that's important because that's the way that it's going to be offered when it gets to the end station. Packet number 1 or carriage number 1 will turn up, and then number 2, 3, 4, and they have to go into that logical order. That kind of makes sense. We've mentioned, however, the fact that it's not always about people. So all kinds of different things can use a railway system. You can stick livestock in. You can put low loaders with cars and machinery. You can carry cargo, freight, okay, and you can carry hazardous material. But all of these different wagons that they use, all of these different carriages that they use, are specifically designed for the payload that's going to go into them. So the ones that take giraffes, for example, have got a hole in the roof, so the giraffe can stick its neck up through and it goes through, and it has to know how to duck when it goes through a tunnel and things like that. You've probably seen those or not. The ones that take a hazardous material have got thicker linings to them, and they've got special things put into place just in case there's an accident. Of course, they don't want that stuff to spill. Okay, so they would go into a different carriage. So they would go into a different packet that's been specifically designed for that payload. So depending upon who the occupant of the carriage is will depend upon what type of carriage it's going to go into. But this is all known, if you like, up here. The users, the people, know when to get into the right carriage. They don't want to get into a carriage and sit next to a giraffe, for example. Well, they might want to, but they don't want to get into one sitting next to a lion, for example, because that's going to be a rough old trip. They also don't want to get into the carriage that's got nuclear fuel rods in, because that's probably going to be a fairly hazardous kind of event for them, either in the short term or the long term. So they are designed and developed to get into the right carriage or into the right packet, okay, at point. Okay, they don't need to be told anything. It's part of their DNA, if you like. The next thing that Bob has got to think about is where does he live? Okay, well, Bob knows his name, of course, and he knows the street he lives on. Bob is number 1, Firebrand Way, and his name is Bob Smith. So his next question is, who am I communicating to? Am I talking to myself? In which case, I can do that. Okay. Am I communicating to somebody on my local network? So am I now going to talk to Alice? And Alice lives at number 4 on Firebrand Way. In which case, he then starts to think about, how am I going to talk to Alice? So what kind of communication am I going to use to Alice? So once he's got himself into the suitable carriage, he's got himself ready to go and see Alice, he then thinks, am I going to speak nicely to Alice? So am I going to knock on the door and introduce myself, and let's say do a little handshake before I then tell Alice whatever my news is? And if I tell Alice the news, do I want an acknowledgement back to make sure that she's safely received it? Okay, so these are protocols that are put into place here. So do I want this communication to be connection orientated by virtue of the fact that we're going to have a little handshake to associate ourselves with each other? And then when I've delivered my message to Alice, I'm going to ask to check to make sure that she's received it. Okay, did you get that, Alice? Is that all right? And she's going to come back with an acknowledgement to say, yes, that's okay. The other way that I can do this is I could just rush into Alice's house and start shouting at her or start communicating to her, and I'm not bothered whether she's heard it or not. Okay, it sounds a bit rude, okay, but it's a way of communicating. And I don't need to establish any kind of handshake with her. So I can pretty much just come in and start streaming my news to her. And whether she gets it or not, I'm not really too bothered. So this would be connectionless in the way that I'm going to do that. But that would be the first thing, or one of the first things that Bob might need to consider. The next thing, of course, he's got to think about is, where does Alice actually live? What's her address? Well, she lives at number 4 Firebrand Way. Okay, so he knows that she lives a Firebrand Way, number 4. And what's he got to do? Well, he's got to convert that then into Alice's physical address. So where does Alice physically live? Where's her door on my local area network? And so once he's got all of that in place and he's suitably booted and attired, he can now deliver himself to Alice. He can go to his local area network, if you like, under his local steam, if you like. Now that might use a small railway system to do it. Okay, it might use a road system. He might skateboard, whatever the protocol is that he's going to get from his house to Alice's house, it doesn't matter. He's still going to use the same road and he's still going to use the same protocols in order to communicate nicely with Alice. Okay, regardless of what type of payload that he's got for her, whether it be a cake or a birthday card or whatever it is that he wants to, however he wants to communicate. That's how he's going to do it. Okay. The next dilemma that Bob has is that after he's been bothering her for several years, Alice has decided that she's going to move to a different street, and why wouldn't she? And so Bob now needs to find where Alice lives. Sounds a bit scary, this, doesn't it? And now, in order to communicate with Alice on a different network, he needs to go to his local railway station. He's still, you notice here, going to get himself into the right carriage. Okay, he's still going to be thinking about whether or not this needs to be connection orientated. Do I need to do a nice little handshake? And I still need to know where Alice lives. As soon as he finds out that Alice lives on a different network, now he's got to go to a different place in order to communicate with her. So he's got to go to his local railway station to do this. So he makes his way to his default railway station, and he knows where that is. It's the one that he always uses when he goes from his local network to a wide network. So if you live in Cornwall or Devon, for example, you always go to Truro or Exeter to go to from your small networks to get out onto the big network. If you live in Somerset, for example, heaven forbid, you would then use your local network to go to Bristol Temple Meads or to Taunton, for example, to get onto the bigger networks that will take you to those fancy places like London and Birmingham and things like that, places where you can only dream of if you live in Somerset. And so you know where your default gateway is. You know where the default exit point is off of your local network. And it's local to you, so you can make your own way there. You use your own car or skateboard or whatever your chosen method of transport is to get from your place to that railway station. Once you get to the railway station, of course, now you are going to get onto a proper train. So your packet, your carriage here, has now got to be connected at this point in time to the train system. Okay, so what we have here is an engine which is going to push you or pull you, depending upon which end it's on in here, but it will also need to know whether or not this is going to be a connection that you're going to establish nicely, and indeed, where are you going to? So it would need to know the address. It needs to know that, of course, so it knows how to connect you to the right rail by using a series of wheels. And I think you train spotters out there now shouting out, so I think you'll find they're called bogies, Phil. I've heard this before. Okay, I'm not a train spotter, but yeah, so they are, I think they are actually called bogies. But here we're talking about the wheels of the train, which connect to the track. And so this would be the interface, if you like, that connects us from all of this stuff that's happening up here to the physical medium of the rail, the actual track itself, the wood and the steel that comes together to make the railway system underneath the rails, that will then allow us to leave the station to go to our destination. And all of this, okay, allows Bob to either communicate locally on his local area network or to communicate from his local area network to a wide area network. And then when he comes off his destination, he then comes down onto another local area network where he can then connect to wherever Alice is now living, or wherever the end point is in his destination. Remember that he's doing that by, in this analogy, by postcode and house number. Okay, now if I was to just stick some numbers into this, and this might seem a little bit random, but 7, 6, and 5, and then the 4s, 3s, the 2s, and the 1s in place. Now, my friends, we have got the OSI reference model given to you by using a railway system. And you can see here that where I was saying it's not a good idea to think about this as a conveyor belt of activity that takes place, because it really isn't. Okay, so you can see that we've got effectively broken down into several different areas, I suppose, really, where we've got the local area network, 765, 4, 3, 2, and 1, all coming together, that allows Bob to communicate on his local area network. So he needs to get himself up, washed and dressed and ready to go speak to Alice. He needs to know whether or not he's going to speak nicely to Alice, and he's going to have a handshake with her before he starts communicating and then getting an acknowledgement back. He needs to know where Alice lives by her postcode and her IP address, her postcode and her house number. He then also needs to know where her front door is, where her physical address is, and how is he going to get there on the road system. That takes us down to layer 1. If he's going to go onto the train system, remember, then he will need to then find his default gateway. Okay, so he needs to then locate that off of his local network so that he can then board the correct train to get to the correct destination. And so we have another part to the system if he's going from a local area network to a wide area network. And indeed, of course, he will also, and of no concern to Bob whatsoever, need to consider the physical way that he's going to do this, the road or rail network that he's using. And in this case, of course, we're talking about railway systems. It just so happens that this also very nicely puts it down into the brackets of when we are thinking about securing this stuff up. Let's go back, let's put our IT heads back in place here now. There are 4 kind of separate components here, 4 separate areas, which we would need to consider from a security point of view. Now, what I'm going to do now is I'm going to just not geek you up too much, but I'm now going to kind of morph the analogy, and hopefully some lights have gone on already, into potentially how the types of technologies that you might be considering if we were thinking about securing these parts of this network. If again we were thinking still with our analogy heads on, oh, by the way, take a look at that slide. You're never going to see anything like that ever again, I have to say, even from the hand of Phil. The giraffe there was just one that I needed to get in, by the way. It was either going to be a giraffe or a unicorn, but today it was a giraffe. If we are thinking about the different component parts and how we're going to secure this up, this then layers in, as what I was saying before, about the way that InfoSec meets cybersecurity. Okay, there are lots of different kind of areas that are coming together in the back of my mind, okay, when I'm thinking about this. So forget about the top bullet points if you can for the time being, and concentrate on the ones at the bottom. So how could I secure Bob as he moves from Bob's house to Alice's house? Well, he could put a big floppy hat on and some false, the false joke glasses and mustaches and things like that. So he's hiding himself. He doesn't look like Bob. That would be a form of encryption for Bob. So if you're looking out your window, you think, I wonder who that is walking down the street. Doesn't look like Bob. Okay, that's because he has used some kind of security in order to hide himself. So he's encrypted himself in order to do that. We can also make sure that only the right people are allowed on the street, and indeed can communicate on the street as well. So we'll put protocols in place that say you have to be a member of Firebrand Way in order to speak to somebody else on Firebrand Way. What we also need to do is make sure that there aren't too many empty houses on Firebrand Way, because lo and behold, if we've got a street which allows for, I don't know, 50 houses, and we're only using the first 10, there are 40 empty houses there that evil dude could take occupancy of, and he could then be a legitimate member of Firebrand Way. So if he's actually got a house number and a front door on your local network, okay, because you have not taken the time and trouble to secure up the rest of the street, for example, and stop unnecessary people coming in and squatting effectively, then there's going to be a whole load of trouble coming your way, because he will be recognized, and of course he will also be a respected part of that network, which means he can deliver all kinds of nasties to your house and it would be accepted. And the way that we can do that, you can see, is by using things like firewalls, switch security, and something called a virtual LAN, or virtual local area network. Now we're getting a bit technical. Okay, now we're moving into the technicalities of how we would do this. Not allowing too many IP addresses, or not allowing too many houses on the street, is all about the way that we will use address management systems on our network. And again, for those of you that do networking courses and you think, well, why do we need to learn how to subnet by breaking up large networks into smaller components, and all of those calculations that they teach you by doing a whole load of different magic charts and 256 charts and all that kind of stuff? Well, this is the reason why we do that, or one of the reasons why we do that, for good IP address management and for good security. There'll also be, in this case, in the analogy, a good neighborhood watch scheme. So we've got each other's backs as a monitoring system, and there'll be a reporting system that alerts us if something unusual or strange happens on our internal network. And we will invariably, of course, have some kind of a member of the team, either a police officer or some kind of security system, which would then hopefully take either some kind of action for us. So that could be it could be active by virtue of the fact that they stop that from taking place, or it could be passive by virtue of the fact that it monitors so it doesn't happen again. At the top, you can see that we're now moving more into the InfoSec world, so securing the data, application, host, and network. If I was to ask the question here, some of you may recognize the angles that I'm going from in here by using something called defense in depth, which is another layered model that we use for data protection, okay, which again uses 7 different layers. So don't get it confused with the OSI, because these are rings of defense, if you like, that we put into place for securing data and data protection on a network. And it just so happens that data is the central point of everything that you do on your network, and then it spreads out to the application, the piece of software that you're accessing it. The host is the computer on which it sits, and the network is the local area network on which the computers all sit. And so it kind of rings out. It's like dropping a pebble in a bucket of water, okay, how it all kind of ripples out a little bit. If we get to the edge of that bucket, okay, and you're then going out onto a wide area network, then we have to take steps to secure the router. Okay, now here we're looking at something called the perimeter. So we're on the edge of your network. And the way that we can do this is have barrier systems, if you like, that control access. So only the right people can come in and out of the station. You may do that with a ticket. A ticket authenticates and authorizes you to use that railway system. Back to the analogy. A ticket, also a token device or some kind of authentication, identifies you to the system and says, yes, hey, you are, not only do we know who you are also authorized to do something, come in or go out, for example, or come in and go out, because these swing both ways. Okay, so, and again, at a railway station, you'll know that there'll be ticket systems and there'll be turnstiles and things that are locked. So it allows you in, but it doesn't allow you out again. So there's one way in and one way out. And all of these are controlled accesses. Now, these are in things like routers and firewalls on your network. That's exactly the kind of function and functionality that that device or that appliance or that piece of software will have on your network. And you all have one of these. Whether you're a home user, whether you're a small business, okay, whether you're an enterprise as well, you may have multiple firewalls, in fact, that are protecting you. And if you think about a large railway station, you may also find you've got multiple layers of defense, physical layers of defense, which are a big door letting you in, and then a turnstile, and then some kind of ticket thing that allows you access to the actual train itself. So there are different ways that you can do this. Okay, and you can also see that there are protocols to make sure A, the train sets off in the right direction, so it's heading on the right route, and indeed that it connects to the correct destination. So Bob doesn't want to get off. If Alice lives in Peterborough, he doesn't want to get off in Edinburgh. Although given a choice, I'd be in Edinburgh well, Peterborough is lovely too, but Edinburgh's cool as well. And so, but it's of no use to him because he is now in the wrong place, okay? And all kinds of trouble may ensue, of course, if he then thinks that he's going to Alice's house, but he's on the wrong network, okay? So that could potentially happen. And so this allows us to use a layer of security here that secures up the transport side of the network. We're then talking about moving of stuff from one place to another. So data in transit, and those of you that are InfoSec people will agree that this is one of the 3 states that data has: at rest, in use, and in transit. So moving from one place to another. How do I actually secure Bob up when he's in a train moving from point A to point B? Well, we've already mentioned the fact we could encrypt him. So he could be wearing his floppy hat and his joke glasses and his false moustache and looking out of the train. And anybody looking in will say, well, I don't recognize that to be Bob. That's because he has used some form of disguise, which doesn't represent exactly who he is. Okay, that would be local encryption. Okay, for the purists out there, that happens at layer 6 on the OSI reference model, if you were wondering. Another great way of doing this is to create something called a virtual private network, or a VPN. And some of you may be actually using a VPN on this call. In fact, so we will be using, in fact, a layer of security on this that allows us to encrypt the data as it's flowing from me to you. We're all using that, in fact. Okay, slightly different to a VPN, admittedly, but the same kind of concept where we're securing up data in transit, and that's the transmission, the transport layer security, I beg your pardon, or commonly also referred to as SSL, secure socket layer. Let's not refer to it as that anymore. Let's call it TLS, because that's exactly what it is. Okay, we also then, remember, have a series of rules that make sure that the right passengers are allowed through to the right destination. So you might not actually physically be allowed to get off at a particular station, for example, because your ticket doesn't allow you to do so. Okay, so again, and all of these are put into place. If we're thinking about this tunnel thing, yeah, we're back to that train thing again. Think about what a tunnel is. Let's go back to the analogy. Think about what do I want to do here? Well, there are several things I can do with the tunnel. I can protect the outer skin of the train, but I can still allow people to see what's happening on the inside. So the tunnel may be made out of glass or reinforced perspex or something like that. So all that does is it maintains the integrity of the payload. So you can't actually physically gain access to it, but I could still see it. In which case, we're not bothered about the confidentiality of the payload. So I can see Bob and his friends on the train, but I can't do anything about it. So I know that when Bob goes from A to B, he's hopefully going to be physically intact. Nothing will have changed on Bob and his party as he goes from A to B. If I don't want you to see Bob at all, so I want to maintain his confidentiality and make sure that perhaps he's a VIP, and I want to make sure that the general public can't actually see the occupants of the train, then I'm going to make it out of something a little bit more less see-through than perspex or glass, and maybe it's going to be a soil bank, or it's going to be concrete tunnel or a steel tunnel or something like that. But whichever method I think I'm going to use, and whatever is the purpose of this, whether it be for the confidentiality or the integrity of the payload that's moving from one place to another, the tunnel sits here. Look at that. Okay, it actually sits between your source and your destination at this layer. So if I then layer in some of these total tunneling protocols that you may have come across, and some of these are a bit old and ragged, admittedly, we've got the point-to-point tunneling protocol that's a layer 2 protocol. It sits at layer 2 of the OSI reference model. Layer 2 tunneling protocol tells you exactly what it does on the tin. It used to be called layer 2 forwarding from a Cisco point of view. And so L2TP actually tells you that it sits at layer 2 of the OSI reference model. IP sits at layer 3 of the OSI reference model. And so that is now securing the data up at that particular layer. TLS, or transport layer security, is the only one really that kind of falls out of this a little bit, because that traditionally it sits at layer 4, the transport layer, but it also ekes into layer 5 a little bit. And this is where this conveyor belt thing doesn't work for the OSI. It's where it's like a merge of stuff, okay, going through. It's a bit like trifle. Okay, so TLS is quite widely used as well. So secure socket tunneling protocol, for example, from a Microsoft point of view. Now, again, there are plenty of other different types of protocols that are used here for VPNs. I totally get that. Okay, but they will invariably all sit here, and that's why. So when these are designed and built and these protocols are put into place, the engineers and the developers that do this for us know exactly what it is that they're trying to do. They're trying to maintain the confidentiality and the integrity, and of course the availability of the data, to make sure that it's safe to go from one place to another. And that's what a tunnel is. It uses a technology called encapsulation to encapsulate, or to surround, if you like, the data as it moves from one place to another. And then we get down to the actual track itself. So the physical security of that. Let's not forget how important that is. And some of you will invariably be part of the team that look at physical security of your network. Remember, here we're talking about buildings. We could be talking about the physical sites that you work in. And this is all secured up, as you can see here, with things like CCTV systems, fences, signage, and things like that. If you think about the railway system again, there's loads of this, isn't there? There's barbed wire fences that stop you getting onto the track. There are signs telling people to keep out. There's danger, overhead cables, and all that kind of stuff. Is this 100% guaranteed? No, of course it is not. And we still hear time and time and time and time again, don't we, that people have got onto the track and that they've stolen the copper cable and there's been an incident at a railway station and so on and so forth. And all of these things take place. So none of this is ever going to be 100% guaranteed from a security point of view. But there is lots of different layers of this that you can put into place, and lots of different kinds of technologies that you can put into place to secure it up as best as you possibly can. The one that generally gets forgotten, which kind of grinds my gears a little bit because it is the one that we should always think about, is the procedural security. Without a policy, none of the above really rings true. So here, and I thank my friends at the office at Rail and Road here, because I've pinched this from their website, are all of the laws and regulations, or some of the laws and regulations that come together. I must admit, when I can put this slide together and started having I didn't look at all of these because I'm not that much of a geek, but I didn't realize that I didn't realize there was something called the Level Crossings Act of 1983, which is, like I say, I haven't read it, but I didn't even realize it existed. But it kind of makes sense, really, from a security point of view, that there should be an act of law in here that not only regulates, but actually determines what would happen if somebody fell foul of this. And again, when we're dealing with laws, regulations, and standards in that order, remember that a law there's not compliance here. You must comply to the law. Okay, you've got no option there. If you break the law, you could find yourself in prison. Okay, if you break a regulation, invariably what you're going to find yourself with is some kind of financial penalty. You probably wouldn't find yourself in prison unless you'd actually broken a law at the same time, like the Data Protection Act and GDPR coming together. Standards, remember, so ISOs sends a shiver down your spine when we start talking about those kind of things. So international standards are what we're talking about here. And again, those are important to us. It's important to know which ones apply to your particular area of business or your line of business or whatever it is that you are dealing with. And those are important, not just for good practice, but also for compliancy and auditing reasons as well. Now, that's kind of morphed over the years into the fact that businesses must meet ISO standards to become compliant in a particular operation. That's possibly not how ISOs were intended, I have to say, but it's not a bad thing, I suppose, really, in the general scheme of things, that's what takes place. Those of you that are facing auditing from ISOs are now saying, Phil, stop talking, because it is a bad thing. It really isn't. Okay, so it's kind of for the good of the company and good for everybody else, I suppose, really. The other types of processes and procedures and policies that you need to be thinking of, things like redundancy, business continuity and disaster recovery. So redundancy is making sure that you've got redundant systems or you've got a second option. So if the trains fail, you can go to buses. A bus service is now running from Bristol Temple Meads down to Reading, for example. Okay, it's only going to be temporary, hopefully, okay, but it will make sure that you're maintaining the availability of passengers that are going from Bristol Temple Meads down to London. Business continuity planning and is something that's been huge over the past 12 months, or certainly the past sort of 8 to 9 months, where businesses have had to take a look at their continuity plans because, of course, the world has kind of turned upside down with, especially in the world of IT, of course, with the way that we need to maintain our systems to make sure that we can continue to function as an organization. And of course, if it doesn't work, we then get down into the disaster recovery side of things, which means that where are our backup tapes? What happens here? And of course, all of this is underpinned by what we're doing here today, okay? And what you should be thinking of from a user training and awareness kind of process and program as well. That's a very, very important process and procedure, and unfortunately, one that generally doesn't get enough credence on networks, in my opinion. In the UK, there's no real get out from that at all. I have to say that it should be part of your internal process. And again, across Europe, I know also my French friends as well, because I watch the channels from the French cybersecurity side of things. We have an excellent system in place from the Protect teams, which are part of your local cybersecurity, local and regional cybersecurity teams, that will quite nicely come up and give you the best advice that they possibly can. They do workshops, they do seminars, they do meetings, they give you everything that you need from a local business point of view and also at a national level in order to secure business up and to take your user training and awareness to the next level. So use and abuse them, find them out. And I know there's a couple of people that are on this call that fall into that bracket, and they're very, very good people. Okay, they've got a lot of good assets and a lot of good resources, but most of all, they've got a lot of good experience and knowledge on how to do this. Okay, so if you are in the UK, dig those out. Okay, I'm pitching for them really, so have a little look at that. In fact, my next, now I'm pitching for Phil, my next session like this, so my next sprint is going to be all about user training and awareness programs, what makes a good one, what makes a bad one, and things to consider. So I think that's coming out. To speak to Phoebe on that one. I think it's November time, end of November, might be beginning of December. I'm up to do that, but it's before the end of the year. So come back and join me for that if you've got time to do that. It'll only be a half a day again, so it'll be like this one. Okay with that. Phew. Definitely time for a cup of tea. I don't know if the yard arm is a yard. Yeah, the yard is well over the yard arm here in Europe. So, but keep to the tea. For those of us that are based in Germany, Belgium, Holland, and France, we'll keep drinking tea, Phoebe.
Okay,
honestly, until at least 2 o'clock. So when we come back, I'm going to get a little bit more technical with it. So we'll start to layer this in, hopefully, and you'll see how this fits in a little bit with the technical side of things, but most importantly, from the security side of things. So fantastic.
Brilliant. Shall we say 10 minutes?
Perfect.
So we'll be back at 5 to 12 or 5 to 1 in Germany.
Perfect.
Thank
Sehr
you.
gut. Schönen Dank.
Phil, over to you.
Cheers, Phoebe. Thank you. Okay, welcome back. Hopefully suitably refreshed for that last little push. So we're going to get a little bit more technical, I suppose, really in the next 45 minutes or so, but not too, it won't be too geeky. But what I do want to do is kind of just layer in, no pun intended, a quick review of what it is that we've just kind of discovered, I suppose, really. So going back to this thing called the OSI reference model, not bothered at all by the numbers in this, although if you are ever going to talk to or become, heaven forbid, a network engineer or systems administrator or something like that, they lovingly start referring to things like layer 2 network devices and layer 3 network devices and so on and so forth. So even though the numbers themselves, I'm not right bothered at this moment in time on this course, get used to the fact that there are people out there that do talk like that. You may be one of them. In fact, I hold my hand up in the fact that I do speak like that sometimes, but you've got to know your audience, haven't you? So when you are talking about layer 3 network devices, don't automatically assume the fact that somebody thinks, oh, that's a router you're talking about, even though you might know it is, because all that does, of course, it just turns you into a geek. You become the train spotter, and invariably then no one's going to talk to you. So the whole beautiful thing about this is when you can then start to translate things. I don't like the term dumbing it down a little bit, but you can get it down into speak that everybody can understand. And that's kind of one of the skills, I suppose, really, of sitting in as either a management position or within some kind of advisory or analytical position where you've got to analyze stuff at a technical level, and then you've got to be able to translate that into either senior executive kind of speak, which technically might be dumbing it down, admittedly, and then getting it down into user speak where people can understand. As soon as they understand, they can get on board with security. And that's, again, something that we need. That's the message, I suppose, that we're trying to get through here. When it comes to the technical side of things, you see here that I've got the OSI reference model. The giraffe is back. I'm pleased to say he's had his moment. But I can also then start to layer in the fact that the labels here are probably more important to us. So 7, 6, and 5, the application, presentation, and session layer, all come together in the TCP/IP model to create something called the application layer. And that's the one that we would generally use on most modern networks. But the kind of things that take place up there is that invariably here we're talking about what's happening here. If somebody goes off onto the internet, and I'm going to demo this to you in a little bit. If I was to go off and do a Google search, for example, I bring up Internet Explorer, Those days are over, aren't they? I bring up Edge or Chrome or Safari or Firefox, whichever is my favorite web browser. Now, the web browser is not the application. Okay, even though we would refer to that as an application or a program, it's not layer 7. Okay, that sits above this. What that has been developed in order to, when you put in www.google.com, it takes your input, sticks it into a whole load of ones and zeros, and it's all aboard. It then puts it into a packet, which is an application layer or a layer 7 protocol, HTTP, for example, the hypertext transfer protocol, which then gets it ready to be sent out onto the internet, because that's how the internet speaks. And so that's then going to be addressed to a web server. Also, as part of these protocols at the top, it could be encrypted or compressed. So remember that Bob could put a floppy hat on and he could squeeze up with his mates to get on board the carriage. And all of that happens at layer 6 of the OSI reference model. So the more data I can actually get into a packet, the more efficient it is, potentially. Of course, the danger with that is, of course, if it goes wrong, the more I've lost. So what I give you with one hand, unfortunately, I take away with the other. The session layer, well, that tells you exactly what it does. It establishes a session. It's a little bit like setting up a communications link. So as kids, you may remember running around the park with walkie-talkies and things like this saying, hello, Phil, this is Bob, how'd you read me over? And all that kind of stuff. Okay, protocols are put into place to make sure that Bob and Phil can communicate with each other. This was before the days that Alice came on the scene. At the layer 4 here, that works very much with layer 5. And here we're now talking about the management of end-to-end communications. And here are two very key protocols, which are the transmission control protocol, TCP, and UDP, user datagram protocol. Now, in my analogy, I mentioned the fact that Bob likes to do a handshake with Alice to make sure that he's talking to the right person. And then when he's delivered some data to Alice or a message to Alice, Alice then has to communicate an acknowledgement back. And that's what TCP does. TCP is what we call a connection-orientated process or protocol. It's very, very old. Some may say ragged, but it's widely used. Okay, it is also very, very susceptible to a whole load of different attacks. So denial of service attacks, TCP flood attacks, SYN and SYNAC and ACK are the communications that take place in this thing called a handshake. And those can also be, unfortunately, spoofed or attacked by flooding arrangements as well. That's quite an easy one to do, in fact. So denial of service, I'm talking about there. UDP, on the other hand, for streaming media. So playing games, listening to music on the internet, streaming live broadcasts, all that kind of stuff, invariably is part of the user datagram protocol. Doesn't require an acknowledgement coming back. If you lose one or two packets of data between the send and receive, it means that the players may pixelate on the screen, or you might miss a beat or two of the music, but it doesn't necessarily interfere with the content. If you miss a packet or two of your email, it means the email can't be read at the other end. So if it's data that we're moving that's got to be legible by the recipient, invariably that's going to go by TCP. If it's invariably stuff where, yeah, you want it to get through, of course, you want it to be as clear as you possibly can. But if I pixelate a little bit, or if you miss a beat of my song or something like that, then it doesn't really matter. You can work out the rest, I suppose, really, when we're using UDP. But both of those are quite commonly used, and they happen at layer 4. The other thing that happens at layer 4 is something called a port. Now, a port is a logical opening on a firewall, which allows for all of this stuff to take place, all of it to come in and out. So that's your front door of your network, if you will. That's an important part of the way that firewalls are built. And the ports are given logical numbers. So HTTP, the hypertext transfer protocol, layer 7, uses TCP, the transmission control protocol, layer 4. And it comes in, the standard port is port 80. And so these are protocols which are established and set on your firewall. If you want to go out and surf the internet, invariably, you would need port 80 for HTTP and port 443 for HTTPS to be open, okay, because invariably most of what you do now on the internet is using HTTPS. It's using transport layer security, and it's your firewall which is set up in order for that to happen. Coming down to layer 3, we've got your default gateway, and I've referred to that as your default railway station, wherever you may live, and that's a router, a layer 3 network appliance or a layer 3 network device. That allows you to go from one IP subnet, so from one local area network to a wide area network, or from one local area network to another local area network, excuse me. And so a router is an interconnection device which sits at layer 3. Layer 2, on the other hand, we're now bringing it down to the local network. And this is where a device called a switch sits. Now, this allows you to translate from IP to the MAC address, which is part of the network adapter. And that takes us back to the way that we were talking about, the way that computers need that physical MAC address as part of their network adapter. And so this is the conversion process, if you like, that allows you to go from a logical system, IP, to a physical system of the MAC address, and the network adapter does that for you. And it uses a protocol which is called the Address Resolution Protocol, or ARP, to do just that, the Address Resolution Protocol. ARP invariably sits at layer 3, but allows for IP to come down to layer 2. Technically, it sits at layer 2. It does most of its work at layer 2. And then we come down to the physical side of things. Here is where it changes. This is where your network adapter does all the donkey work. It converts all of those ones and zeros into physical pulses of energy. So it turns it into an electromagnetic pulse or radio frequency at 2.45 gigahertz, whatever it's sending it out on, but it puts it on the wire. And it does that by creating something called a frame. Now, the train is about to leave the station and it's ready to go, and it's all controlled down here at layer 1 and layer 2 by your network adapter. Your network adapter does a lot of good work for you. Happy days. It can also get you into trouble, of course, just like your mouth does a lot of good work for you, but it can also get you into a lot of trouble, I have found in my experience. Let's see how this all works in the real world. Now, some of you are thinking, hold on a minute, on LinkedIn, he said there's going to be a train and a giraffe. Where's the badger coming? So here in my demonstration, what I've done is I've gone off onto the internet and I have downloaded a picture of a badger. There it is. And so for this demonstration, normally, again, if you're coming to firebrandtraining.com, and why wouldn't you? We'd get you to play around with this, but you can do this at home. Okay, Wireshark is a protocol analyzer, network sniffing tool, which is free to use, free to download and use. It's a very, very powerful tool, Wireshark, widely used by pretty much all of the network communities from a security point of view, from a network and analyst side of things, performance monitoring, you name it, Wireshark will do it for you. Great protocol analyzer is what it is. I think when you open it up, it says it's the world's best, and it probably is. I have no affiliation with them whatsoever. So what I've done is a couple of days ago, in fact, I did this to make sure that it worked. I went off onto the internet, used an HTTP connection, which invariably these are quite rare now on the internet. And I found this picture of this badger and I downloaded it. And so what I'm now going to do is, for the purpose of the OSI, is just show you how in the real world this actually works for us. Okay, so what have I done? I've put into my web page, www.badgers.org. Again, big up to them. Thank you very much for allowing me to have access to this picture. I have no affiliation with them whatsoever. And I've then gone through, I've surfed through I've sniffed through their network, not sniffed through, that's the wrong term. I've found my way, navigated through their website, found a picture of a badger that I liked, and I've clicked on it and opened it up in my browser. That's what I did. And I did all of that from the safety and comfort of my own home. And I did that with Microsoft Edge. Okay, or Google Chrome. I can't remember which one it was. I think it was Google Chrome, in fact. So then I had a network sniffer on, and I captured the data. So I captured that packet, those packets, as they were flying from my computer out onto the internet and back again. And so this is the result of that packet capture that I've done. And invariably here, what we're looking at is the OSI, but in reverse. So where you can see highlighted, you can see here that we're using a layer 7 application protocol, which is HTTP, Hypertext Transfer Protocol. And what I did through my browser was I sent a request, which was GET. The GET was sent to a website out on the internet. And it said, go get from this folder, this file, which is called gallery_euro_badger.jpg. Okay, and use HTTP to go get that for me. What it returned to me invariably through my browser, and this is the user agent you can see, and this is also known to the web server, I have to say as well, so they knew where I was coming from and what I was using in order to get hold of this picture. Okay, was that's the content of this particular capture that I've taken a couple of days ago, I think it was. So if I was to actually take a look at the ones and zeros that came back to me, I would see that picture of that badger. There it is, in fact. Okay, the picture of the badger is within this packet, or within this frame of data that I have captured. Next down the list then, so we've gone from 7, 6 and 5, we need to know what happens at layer 4. So here at layer 4, HTTP is used the transmission control protocol, easy for me to say, the transmission control protocol, TCP, and you can see we're now talking about port numbers closely aligned to what my firewall is going to allow in and out of my local network. So here you can see, hopefully, quite clearly the ports that were used. So port 80, I can see as the destination port. I've not highlighted it for you, but I'm wiggling my mouse. Hopefully you can see that. Destination port 80. Okay, and you can see the source port and destination port, all part of TCP. Now, again, I'm only picking out the bits that we're talking about here today. For those of you that are eagle-eyed, will see that here at layer 4, there's a lot going on, like sequential numbering. And indeed, there's a whole lot, because this is TCP, there are also a whole load of TCP arrangements in here with the flags that are set, okay, for the acknowledgements that are coming back to say that this picture has been safely delivered back to Phil's computer. Then we go to layer 3. Layer 3, you remember, is all about IP addresses or addressing. And so here I can see where it's going from, source, to where it's going to, destination. And again, those of you that have studied it a little bit will know that this is going from a private internal class C address. 192.168.1 is the IP address of my local network, and 15 was the number of the computer that I used in order to get out onto the internet. 173.205.126.118 is a public IP address for a public web server, probably a hosting company somewhere in the States. In fact, this one is. Okay, and those are the people that are now looking after the badgers.org website for them. It may be badgers.org themselves. I don't think it is. However, I think it's a hosting company. And so what we're doing here is we're going from a private network, my internal network, to a public network. And how are we doing that? We're using network address translation on my local router downstairs in my living room. And all of that magic is taking place without me having to do anything. The router is doing all of that work for me, and it's working here at layer 3 for me. It's a layer 3 network appliance that takes IP addresses from one to another, layer 3. Layer 2 here is where, remember, what's happening here is I'm sending this packet to my router. So I'm finding my default gateway to use a train, if you like the analogy, to get off onto the wide area network to go get that picture of a badger for me. Go get the badger for me is what it's doing. And so this connection that you can see is from the MAC address of my local machine to the MAC address of my router. So when we're looking at this at layer 2, it's converting the IP address to the MAC address, so the physical address, so it knows physically where to send it down the wire it's connected to the local router on my local area network. And you can see here quite nicely that Wireshark, not only does it give me the MAC address, which is written in hexadecimal addressing just to confuse things even further, but breaks it down into, effectively what it does, it breaks it into two different parts for me. The first part of your MAC address identifies the manufacturer of the network appliance that you're using, the network interface card, and the second part will actually be the unique identifier for that particular appliance. So here you can see, again, without having to translate it too much, that it's going from a Microsoft device, which is my Microsoft laptop that I'm using for work, and then to the Sagem.com network device, which is my orange home router, which is downstairs in the living room. And so this is where my machine has been able to find the default gateway from MAC address to MAC address in order for it to go out onto the internet and send that GET request on my behalf. Okay, the network adapter itself, my network adapter, has done all the donkey work for me. So down here at layer 1, you can see here, hopefully, that my network adapter has turned this into a frame of data. It tells me how many bits and bytes are part of this, and how many bits and bytes is it actually putting on the wire. That's because it's using an Ethernet connection to do that and cabled in. Okay, it's going down an Ethernet connection. You can also see the date and time when this is delivered. So if I'm tracking my train, when did it safely arrive at its destination? Well, I can see the date and time. And again, invariably here, you can also see that I'm using Western Europe Standard Time. Okay, even though obviously Britain invented time, our clocks are all wrong over here in Europe because obviously we didn't invent time, the Brits did. apparently. And so what else do I get from my frame? Watch this. There's my train leaving the station. So if you like the analogy, in the way that you can layer in all of these different protocols, if you like, all in one big ball of energy with a whole load of protocols that are stacked together, just like a train at the front, the carriages all lined up behind with the wheels attached, all ready to go. We've now got the Ethernet train, which is pulling the IP header, the TCP header, and the HTTP application protocols in order to go get a picture of a badger for Phil. Okay, and this is the train now effectively leaving, okay, and doing that work for me. Okay, all of those protocols coming together are part of the OSI reference model. So here, wrapped up in the protocols in the frame, you can see that we've got 7, 6, and 5, 4, 3, and a little bit of 2, and a lot of 1. Okay, as it's moving from my network interface card down a wire through my router and off out onto the internet to do everything for me. And that is the technical side. That invariably represents all of those ones and zeros that are coming together every time you go off and surf the internet. So it's playing its part for us. But the beautiful thing, of course, is it's completely transparent to us. The only time that you would need to get into this is if you're building it, troubleshooting it, engineering it, or developing applications that need to know these protocols to do it. Okay. From a security point of view, however, it's important to know roughly what's going on in the background, because as we start to look at what could be happening in here, what could be going wrong, there are a lot of different areas, I suppose, really, when we're looking at it, especially at the upper echelon, where we're talking about applications and transport control protocols and things like that, where things can go wrong. There's a lot of vulnerabilities built into these protocols because they are old. The old protocols that we are still using work. It's a bit like, originally I'm from Somerset. You might have picked up on a little bit with the twang. Nowhere near as broad as my family who still live in Somerset, who frankly, I don't understand them. I don't understand them anyway, but when they start talking, I don't understand them even further. And so what happens here is, back in the good old days, in the 1960s and 1970s, when I was a lad in Somerset, we used to leave the key in a flower pot behind the back door. Sometimes you just used to go out and leave the back door open. It made no difference because nobody robbed your house in Somerset in the 1960s. There was no badness in the UK in the 1960s and 1970s, kids. Obviously, that's not quite true, but it is true in the fact that I cannot remember ever coming home to find that our house had been robbed, okay, or somebody strange was sitting on the sofa and things like that, okay. But it means that, of course, that if you were still these days on a modern network, I'm very sorry to tell you that if you leave your key under a flower pot outside of your house or leave your front door open, you're going to come home and find your stereos nicked or somebody squatting, because that's the way, unfortunately, that life in what we in 2020 now revolves around us. So the threats that we have against us, okay, have now meant that the risk against our unprotected networks and our unprotected assets, if you like, are now greater than they were 20, 30 years ago. These protocols that we're talking about, folks, are 20, 30 years old and were designed for networks that had no idea or understanding about the types of threats and the types of actions that people could dream up of. I take my hat off sometimes to the criminal element about how spookily wise and imaginative they are in the way that they actually continue to defraud us and attack us with new techniques time and time again. Every time you think you shored something up or you found a solution for a security vulnerability, they're one step ahead of you. Okay, they are good at it, I have to say as well. And sometimes, unfortunately, it is also down to the weakest link on your network as well. That's going to be my final point. Okay, don't worry too much about the ones and zeros. Let's think about this from a security point of view, and then let's get back into what we do on our day-to-day business for those of us that are involved within a security environment. So it doesn't really matter what job you have, what role you are, we're all on board with this. And it doesn't matter if you're a user, it doesn't matter if you're an IT administrator, whether you're a developer, whether or not you're coming in from a management point of view, this applies to us all. Okay, so it doesn't really, I don't really care about the level in here. Policies are the first and foremost. Okay, so if you're a policy writer, I'll take my hat off to you. Okay, it's good work. From a technical point of view, possibly would I class myself as a technician? Probably, possibly yes. I suppose really it's more of what I do. policies, something that you get dragged kicking and screaming into, isn't it? The paperwork side of things. But in all honesty, folks, I've come to love them. A good policy is worth its weight in gold. Okay, it tells you exactly what you need to do, who does it apply to, what's the scope of the policy, and most importantly as well, in a lot of them, what will happen if you fall foul of the policy as well. So there may be some disciplinary in here as well. Now I'm going to park this for a little bit because the user training and awareness side of this, I'm going to save for another day because I'm coming back to discuss that. I think that's going to happen in November if you're up for a little bit more of this action. When it then comes in from the physical side of things, some of you may be involved in this. Well, let's cut to the chase here. We're all involved in it, aren't we? If you leave the office door open when it should be shut, there's a policy there, of course, that tells you that you must, the last person in locks the doors and turns off the lights and all that kind of stuff. And if you don't, then there should be some kind of disciplinary action against you. All of these things, of course, are in to protect your network in a very oblique kind of way, of course. The fences, the signs, the bollards, the CCTV systems are all in there. And part of that is, of course, network defense and security. Everybody, again, has a role to play in this, whether you're a user, whether you're a manager. It's not just down to the CCTV system and the guard, the physical guard, if you've got one of those, to look after you from a security point of view. It's everybody's mandate to do this, okay? This is my world. I suppose, really, if I was to be brutally honest with you, this is what makes me, like I say, makes me get up in the morning. It isn't. It's a cheap bottle of wine in the local supermarket that gets me up in the morning. Said that wrong, but you know what I'm saying. And so this invariably is the technical controls that we put into place. Now, again, you can see here that we're talking about things like firewalls, routers, and switches. Those are physical things that you can touch. Well, a firewall doesn't necessarily have to be, it can be a piece of software, but a router and a switch, that's the thing that's downstairs in my case, it's downstairs in my living room that I keep lovingly alluding to. Okay. And that's the thing, the physical connection that allows networking traffic to come in and out of my network. How important is that to the security of my network? Well, it's vital, absolutely vital. It's the first line of defense, potentially. But then we get into the soft side of things, if you will, the software, antivirus. Your firewall may build software as well, remember. Your VPN is a piece of software, invariably, that's allowing you to connect out onto the corporate network. And then we get into the policy side of things here. So we're talking about access control systems, authentication, auditing systems, and then this beast called group policy. And if there are any sysadmins out there, you will know that this is a technical control that invariably allows you to play God on a network. Those of you that are good with group policy will know that you can control pretty much everything these days by using a series of technical templates and controls. Within Active Directory, it's probably at its best, but you can also use this locally and apply it locally. So if I want to lock my users out of getting into internet sites or downloading stuff from the internet, not plugging in USB devices, all that kind of stuff that we have to contend with on a day-to-day basis, group policy allows me to do all of that from a technical point of view. And the best way of doing this, of course, is to layer it all in. So don't just rely on one technical control, use multiple controls to do this, okay? And again, multiple controls also includes, of course, procedural and physical controls as well. The security of devices, again, this is kind of mainstay security, I have to say. So authentication, remember what that is, proving to the system who you say you are. Okay, and so remember that these are broken down into what we call factors. Multi-factor authentication, 2 or more. Big business for us now. Okay, passwords should now start to be a thing of the past. They won't be, of course. We're still using usernames and passwords to gain access to something, and why wouldn't we? But let's layer that in now with it then sends you a text to your mobile device, so it's something that you have as well as something that you know. You may use a biometric device to log onto your system's Windows Hello, for example, face recognition, fingerprint scanners, iris scanners, those kind of things, biometrics. There are a couple of others here as well, so something that you do and somewhere where you are as well, so you can actually authenticate somebody by a handwriting, for example, something that they do. It's not a particularly good one, I have to say, and something somewhere where they are, so a geographical location, where are you on the planet? So it may mean, of course, that you could use a technical control to stop somebody from gaining access to confidential material if they're not physically on your local area network. And all of these are authentication factors that we put into place. Encryption, Well, for those of you that were lucky enough to see me on my first sprint, I use the term lucky there kind of loosely. We spoke about encryption there, so it was all about cryptography. That one, I don't know if you weren't on that one and you're interested in it. I'm sure there's a video somewhere that Phoebe will be able to give you a link to at the end of that. So demystifying cryptography, I think we called that. Again, another one of my bags, really. I've been involved in encryption for a long time, from the ground up, really, from building it, breaking it, and using it. And again, that's another big subject area, really, which is a technical control, which you can layer in all kinds of things. Encryption looks after invariably the integrity and the confidentiality of your data. Okay. And again, I'm now layering in some fairly good terms. Those of you who've done a bit of training will know the terms that I'm using here well. Okay. And again, you can also see then from a device security side of things, make sure you've got a good firewall and that it's routinely managed and updated. Windows updates or patches, if you're a Linux kind of dude, that also then gets updates. Make sure, or a Mac user, make sure that you are using the update controls on that and update your system. Do not think that just because you're using Linux or Mac that you are not susceptible to virus or any kind of malware. Of course, those days are over. People now know that that's not true. And well maintained. Also make sure that any unnecessary, unwanted applications are removed from your devices. Huge these days as well. I'm also talking about mobile devices as well. So if you've got one of these and who hasn't got one of these, have a little look at your mobile phone or your tablet and just take a little look at those games, those apps and things like that. They were fun, and especially in lockdown, who didn't download a whole load of serious crap onto their phones in order to go TikToking and FaceTiming and all that kind of stuff and playing games and things like that. Again, I'm not being too disparaging about those applications. In the right hands, of course, they are fantastic. But if you're no longer using it, if it was a 5-minute thing that you did with your friends or your kids and things like that, and you're no longer using it, get it off your device, move it off, delete it, remove it. Okay, because what you probably don't understand is that that is calling out onto the internet on your behalf, and it's synchronizing data, and you have no idea that it's doing that in the background. This is a definite in at the moment for a whole load of intrusion attacks and fraud, and a whole load of cyber criminals, in fact, are acting on this as we speak. So good mobile application security at this level will go a long way. Have a little think about that after this course, I would suggest. Okay, see if that's you. When it comes to the layer 3 side of things, then we're talking about a router. Okay, from a geeky side of things, we refer to that as a layer 3 device, and that's what it does. I'm not going to read the slide to you, but you can see here that it moves traffic from one network to another. We lovingly refer to that thing that gets us out onto the internet as a router, your wireless access point. Okay, some people still refer to it as a hub. Why not? I don't care what you call it. Okay, it makes no difference. But it's more than that. Okay, not only does it get you from an internal network to an external network, it will also provide you with an IP address using a protocol called DHCP. That's a layer 7 protocol that works down at layer 2. It also acts as a firewall for you, which works at layer 7, 6, 5, 4, 3, and 2. Okay, so it's working at multiple layers. Some people like to refer to that as a multi-layer network device, I have heard. That person invariably is me I'm talking about. But as I've said here, that if you went into, if you were doing a network support job, or you were talking to your family and said, oh, has anybody played with the multi-layer network device? Everyone's going to look at you and invariably throw things at you. And in my mind, they'd probably be right to do so, because that really does make you look like an ultra geek. So keep referring to it as a router, but make sure you know what it does for you. Okay, I don't care what you call it a hub if you want, or a thingy, a doofer, whatever you want to call it. But the next step here, and hopefully my Protect officer friends will all start nodding, is have a little look periodically at changing some of the security settings on it. If you haven't ever done this, do this. Okay, I'm pleased to say that most of them now come in and they force you to change the default security arrangements on them. So the default passphrases. The one that folk forget about is the default admin account and password. Do you know that you have an admin account and password on your local device, which allows you to go in and change the settings of it? Okay, most of these also these days come with a whole load of built-in security appliances that allow you to restrict access and content out onto the internet if you've got small kids, for example, or if you want to put timing restrictions on so your kids aren't out on the internet all day long. Have a look at the firewall periodically as well, because every time you open up an application on the inside of your network, it goes and knocks on the firewall and opens up a port at layer 4. And it then says, right, I can communicate out on the internet. The problem with opening a port is like opening up another window in your house. And if that's a downstairs window, which is insecure, someone's going to come in, someone will find it and be able to either use a security mechanism against it or just step in, because it is sometimes as straightforward as that. Some of the biggest attacks that we've seen on internal networks, in fact, denial of service attacks and the like, have been from these plug and play smart devices where people have just plugged them in, CCTV cameras in particular, IP cameras, plugged them in, they work perfectly, but what it's doing, it's opening up an insecure port out onto the internet for remote management. Hackers know these ports, okay? They also know the applications that they can use to get access to the inside of your internal network. And trust me, you do not want somebody to come through, so for example, port 23, open telnet ports, or remote desktop protocol ports, port 3389, to come onto the inside of your network in order to remotely control it, or at best see you on your own CCTV system, at worst take complete control of your network, and maybe even drop ransomware for good measure as well. So again, it's well worth just having a little look. Think about it as your house. Imagine not necessarily checking that dodgy window that keeps opening and flapping in the wind. You would very, very quickly do something about that. You'd secure the catch, you'd get a new lock for it, you'd get that fitted. So why not add that kind of concept to your firewall, to the router, to the appliance that's sitting there, allowing you to invisibly get yourself out onto the internet. Okay, there's a lot that goes on there. Have a little look at it if it's unfamiliar to you. But the thing I will say is, like the last bullet point here, don't do nothing, do something. Okay, if you do just a small part of this to protect your network, you're doing some great stuff. Okay, you are doing some great stuff, and you may not necessarily be stopping an attack, but you are certainly slowing it down and making it awkward. And hey, let's slow it down and make it awkward. Don't make it easy for them. Okay, when we come to layer 2, we're looking at switching technologies. Now, this is definitely going up into systems administration, network administration, and engineering side of things, which for the majority of us on this course, we're in no way, shape, or form going to be too bothered by this. If you're interested in this, this would be like CCNA kind of stuff, I suppose. So looking at port security, CCNA security, those kind of things. And there's a whole load of stuff. Switches fall into 2 categories, a managed switch or an unmanaged switch. And if you think about what a switch is on a railway network, okay, it's the points which allow it to connect so the rail can change going from one network to another. And again, that needs to be kept nice and safe and secure so no one can tamper with it. If somebody can get in access to that, they can definitely do denial of service, or they could monitor the trains going over it, but they need to get physical access to it in order to do that. So here we're going back to a layer of physical security to stop people getting there in the first place. Comms room security, for example, don't let people just wander in to have access to the switches. If you're in a building where you've got your switches, I'm doing this because invariably they're up high, they're in a little wooden box and you can actually see the switch panel, or it's on a floor, it's on a dodgy table somewhere in the corner of the office. Don't do that. Secure it up. Don't let people have access to it, because as soon as you've got physical access to a switch, or somebody visiting your network has got physical access to it, terrible things can take place. You all have a switch at home, in fact. So if you pick up your home router, have a look on the back, you've got a 4-port or a 2-port unmanaged switch on the back. And again, that's where you plug in your Xbox and your PlayStations and things like that, because it's quicker and more secure. Okay, we generally as home users don't need to worry with any of that because we're not allowing people access to it, okay, from a physical point of view. So we don't need that layer of technology on our unmanaged switches at home, okay? But on an internal network, on an enterprise network, these are things that you would need to consider. Coming towards the end then, so looking at the firewall, the first line of defense, okay? Now, 2.5 hours ago, I started talking to you about Bob and Alice talking down Firebrand way, and your mouth and your hands and your eyes and ears and all that kind of stuff. Okay, 2.5 hours in, we're on slide 39 out of 42, you'll be pleased to hear. And I've now put a firewall rule in front of you, which is saying allow and deny direction, application protocol, IP address, and a port number. Okay, this is the, if you like, the gauge, the filter that allows for traffic coming in and out of your network. Now, I'm not going to insult your intelligence about what does allow and deny mean, and in this case, it allows something to come in. And I'm not going to insult your intelligence about the direction here. It's inbound, so it can come in. But if we think about these protocols now, HTTP sits at layer 7 of the OSI reference model. And we've both seen that from the train station analogy, from the list, and indeed you also saw me Wireshark capture this at layer 7, 6, and 5 with that HTTP connection that I made. Okay, if we're now talking about IP, I can't hear you shout the answers, I have to say, but shout the answer out. IP sits at which layer of the OSI reference model? Well, that sits at layer 3. Well done if you got that right. And then if we're talking about TCP, the transmission control protocol, and indeed the port at port 80, which is associated with HTTP, where does that sit on the OSI reference model? Layer 4. Now, I have to say, if you answered those correct or partially correct, you have to take a good look at yourself, because you have now, in the space of 2.5 hours, become a geek. Okay, well done. You're now speaking the language of a network infrastructure technician who talk about layer 3, layer 4, and layer 7, and indeed layer 2 a lot. Okay, but if you can get just that little bit from the couple of hours that we've had together, perfect. Okay, that's what we're trying to achieve here. Okay, an understanding, I suppose, really from the networking side of things of what's going on in the background. Okay, the other point here when we're talking about firewalls, okay, is that it is very true that your firewall is generally seen as the first line of defense. I train a lot of courses which are the Certified Network Defender course. In fact, is one of my favorites. In fact, take a look at that, because that's just been renewed. If that's an EC Council course, CND. It's awesome. In fact, I had the pleasure of reviewing the courseware this week for EC Council, and it is a super course. However, that goes into a lot more technical depth and detail that we're talking about here today. But when I deliver those courses, I'm delivering it to invariably people at intermediate level. When I say we talk about network defense and things like that, firewall, 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 firewall is pretty much all I hear from probably about 80 or 90% of the answers I get. It's all about the firewalls. Well, you've seen hopefully from today's little session that it's not all about the firewall. Okay, there are certain layers of defense which need to be put into place in order to make it happen. But a firewall is an important aspect to this. Okay, let's look at the however here. Okay, because with all of these controls that we put into place, let's go back to the railway network analogy. We can have a super fast, super efficient, super secure network that supports our railways and our trains. But unfortunately, I can also guarantee you that several times a year, it's going to break. It's going to stop working. There may be an accident. Somebody's going to vandalize the track. Somebody's going to steal the copper. Somebody's going to graffiti the walls. Okay, at different layers of attack and different levels of networking intrusions are going to take place. But I can guarantee they're going to take place. A lot of that is down to the fact that these are, of course, implemented by people like you and I, the users. We're always going to be that weak line effectively in the technology because it's set up by users. And someone's beat me to my punchline, but fantastic. So I think it's one of my German friends. Schön, vielen Dank. And so the user here is invariably going to be the weak link. Okay, users are trouble to us. Okay, that's where I was going. It's an in-house joke, and you might have seen it on the chat. In fact, that layer 8 problems are lovingly what we call our users when they phone the service desk. If you are a user and you phone the service desk and all you hear is like a muffled sound and saying, yeah, it's a layer 8 problem, that's your IT service desk admin being rude about you. There are several others, of course, problem in chair, not in computer, picnic. And there's a whole load of these things. Some of them are ruder than others. But we lovingly refer to the users that have made the mistakes, okay, that are the weak link in the chain, to being the layer 8 problem. Of course, layer 8 doesn't exist. It's a joke. But there it is. And it's a reference. It's a geeky reference, of course, to the OSI. Layer 8s are your biggest problem, okay? The problem is invariably not the technology that you're using. It's not all that wonderful equipment. It's the user. invariably that comes into this. Now, this might not necessarily be something that's deliberate, okay? We're not talking about people that are deliberately coming onto your networks in order to threaten it. It's just that simple clicking on links, replying to emails, answering the phone and giving away information, doing things that they're not supposed to be doing, plugging in USB devices, all of those kind of things that we allow our users to do freely on a network, invariably is where the risk comes from it. But as you can see here, we can't do anything about it. We have to live with it. We have to maintain this, because not only are they our biggest problem, they are also, folks, our biggest asset. And so without them, we have no business. Okay, we have no network, we have no business, we have no real reason of why we are doing what we do. Okay, so love them or loathe them, they're here to stay, of course. And again, because I've not mentioned it fully, and no security course would not be worth its weight in gold without some idiot instructor saying the CIA of security to you. So there it is. Okay, we need to maintain our networks. And this is that great old data protection framework that we talk about all the time, about the confidentiality, the integrity, and the availability of your users. And hopefully, as I've been talking to you, whether it's been about a train system or whether it's been about an IT system, giraffes and badgers, the confidentiality and the integrity and the availability of the network have been absolutely supreme in everything that we do. And so my kind of parting shot to you is that we have to look after them. Okay, if you protect your users, if you keep them well maintained and well trained and well updated, okay, and in the right kind of framework that we want to be in from an OSI point of view. Unfortunately, you can't shove a cable up them and update them and patch them and things like that. I think that's probably illegal. Don't know about Europe now, or don't know about the UK now, so I don't know how that works, but it probably is. Let's say that it is. So we have to protect them by using training and awareness programs. We have to protect our network by putting in layers of defense, procedural, technical, and physical controls. And mostly important to us, I suppose, really, if you take nothing else away from this today, is that you need to protect yourselves at home. And of course, you need to protect your businesses in the same way. Okay, what you adapt and adopt in the workplace, you should also be doing within your home environment as well, and vice versa. Okay with that. Superb. Layer 8s. And that, ladies and gentlemen, boys and girls, I think wraps it up. I'm about 5 minutes earlier than Phoebe wanted me to be, but I think I can possibly live through that. I'm certain that you can live through that. It's Friday afternoon. What I would say before Phoebe kicks in is be my friend. Okay, by all means, capture my email address and use and abuse that. Find me on LinkedIn if I'm not already a friend of yours on LinkedIn, and let me know what you're up to. Keep in touch. Phoebe is your point of contact for all of the other great sprints, in fact, that Firebrand are doing. And why wouldn't you want to do those? I have to say. So there's a whole library of different technologies, not just security based as well. There's a whole load of great learning to be done with these as well. So I'll promote those to you as well, because they're really good. Okay. My next one, I can't remember the date, but Phoebe will let you know when it is. It's a user training and awareness session. I think it's in November sometime.
30th of November.
When is it? Sorry.
30th.
30th of November. There it is. Okay, so if you're about and if you've got a free couple of hours on a Friday morning, then it'll be fantastic to see you. I hope this has been of some use to you. I hope you've enjoyed it, really, is the main thing, and that it kind of hammers home some of the points through actually enjoying it. Thanks very much for all of you that have stayed with me as well. It's been amazing, a great response, and I appreciate it. So hopefully you've appreciated it too. So Phoebe, over to you.
Well, I believe now we can open up the floor for Q&A, really. So
Perfect.
if anyone has any questions, please feel free to pop it in the chat box to the Everyone group, and I will send them over to Phil. So first question is, beg your pardon, let me just have a quick look. From R, in which way do the aspects you told us change when moving into the cloud, either IaaS, PaaS, or SaaS?
Yeah, really great. Okay, so when we're talking about the cloud side of things, so what we're talking about there, so IaaS, infrastructure as a service, platform as a service, and software as a service are the three main ways, I suppose, really kind of cloud is used. One of the key things here is it's underpinned by pretty much everything we've just said. Policy is invariably going to be the first thing here, especially if you are offsetting your or outsourcing your security. And indeed, if you're outsourcing your data, of course, into these cloud providers, especially if you're looking at storage as a service, which is not on the list, but infrastructure as a service in particular, you must make sure that you're watertight on your service level agreements to start off with that, whoever your cloud service provider is going to be. Ultimately, of course, what you have to remember as the data owner is that you are going to be responsible for it. So even though you have outsourced to the cloud for whatever purpose, you still have to maintain the main concepts of what we've spoken about here today, and then some, in fact, in order to, from a data protection point of view, of course. From a physical side of things, from a networking side of things, of course, you would always then make sure, and this is particularly good, this is a great question, from a software as a service point of view as well, if you're using Office 365, for example, is the vulnerabilities that come into play there from, dare I say it, Slack administration, where the administrators have invariably left your business open by not using the correct authentication protocols and or indeed mechanisms. Microsoft are very keen on you using multi-factor or bi-factor authentication, and in particular as well, leaving open ports open if you're using virtualization assets up there as well. Time and time again, not in recent times, I have to say, but I've seen port 3389 RDP sessions opened up into cloud assets as well. So that's exactly the same kind of layer of defense that we're talking about on an internal network, and nothing really changes other than the fact, of course, that your assets are now somewhere else. Okay, but invariably, of course, all the cloud is just an internet-based resource. So the same kind of theories apply. So unfortunately, I don't know your full name. That's a really great question, I have to say. Really good, fantastic. Did that answer it? That's I suppose that's my question back to you. Is that what you wanted to hear?
I think in the meantime, yes, R is for Rainer.
Perfect.
What I'd like to ask is, what sort of courses would you recommend if you are non-technical and wanting to start off in network security?
Perfect. Okay, so probably there are several kind of key ones, I suppose, really, which are the foundation for us. Network Plus, CompTIA, is always the mainstay, the go-to really for this, because it's always reasonably well updated. It's vendor neutral, and it's a quick and easy course. To be honest, so it's not when I say quick and easy, it's a nice, quick, sort of to the point kind of course. The exam itself is quite a challenge, but why wouldn't it be? There's no point getting a credential if it's not going to be a test for you. But it also means something to people. Microsoft have their own MTA, so Microsoft Technologies. Again, those are okay. I'm going to put those in the bracket of okay. Again, I apologize if there's anybody from a Microsoft point of view, Microsoft call on here. They're okay. They're foundation level, and they deal, if you're going into a pure sort of Microsoft environment, they're very good. But of course, then you should start looking at Cisco, CCNA settings there as well. Now, that's more intermediate to advanced level, I have to say. Once you've cut your teeth on Network Plus, then the world is your oyster, I suppose, really. You can then make a decision about whether or not you're going to go down the Microsoft route, down the security route, down the management route, or indeed down the Cisco route, which invariably what networking is all about. But it's a good foundation entry level for the networking side of things. If you're coming in from a security point of view, Security Plus, once again, CompTIA, another great course, has just been recently updated as well. And the one that I've just briefly mentioned as well, the CND, the Certified Network Defender from EC Council, awesome. It's a really, really great course. It was always good, I have to say. I put it into the bracket of it being good, to the point it's now been updated. So there's a fresh one that's out now, just out, in fact. I think it was launched at the end of October. And like I said, I've taken a look at that course where I'll be delivering that, in fact, in the new year. Really great. It's a really great course. It's a tough challenge. There's a lot to it, but it is very, very good. And that's seen as a foundation course from EC Council for you to then go into the higher echelon, so into ethical hacking, into security practitioners, for example, and also into information security officers and things like that. That was a good question from you, Phoebe.
Thanks, so. We're just going to open the floor up for anyone else that is interested in asking any questions. What sort of prerequisites should you have before you arrive to network security? Is it quite free to be in a non-technical position to do it, or should you have some kind of degree,
No,
or how
no.
does that work?
Yeah, it depends on, again, it depends on where you're coming in from. So from a management point of view, it really doesn't really make any difference. So where we're talking about risk, for example, threat risk analysis, that kind of thing. If you're going into cybersecurity, then it would help to have a grounding in network security, I suppose, really, or some kind of foundation in security in general. So, but generally speaking, with those courses that I've mentioned, just come with an open mind. There are no real prerequisites for it. Just come willing to learn, an open mind, and willing to discover. I think really that's the thing, is the fact that, I mean, I'm now 55 years old, and every day is still a learning day for Phil, because there's always a new threat, there's always a new technology, there's always something new, a new network component or something like that, which is you're going to meet that challenge with. So if you like that kind of dynamic environment, cyber in particular these days at this moment in time is a great one to get into. And of course, if there are any of you that are looking for cybersecurity apprenticeships, there is nowhere finer than Firebrand training. World class, in fact. And again, I know that I'm bound to say that, but I truly believe in that. Okay, it's a great way for not young and old, in fact, that want to venture into this, to get a whole series of different certs. And again, that's changing in the new year as well. So keep an eye on that as well, because I think it's going to get better.
Brilliant. Stefan has asked, is a SOC as a service a good option?
Yes. Yeah. Again, it's that outsourcing thing again. So you need to choose the right one. Make sure you get the right service provider in there as well. And invariably what it means, it relieves the pressure on you on the inside of your network to a degree, but you also need to have a very, very good, of course, arrangement with whoever you're providing that to, or whoever's providing it for you. There are some good ones out there. I'm not going to do product placement for you, because you possibly already got one in line, but yes. And it's also very popular, I have to say. It's nothing new, that.
Great. Suwana also has a question. What is the minimum knowledge level to set up and support IT for startup SME?
Is that from a security side of things, Suwana, are you talking about? Or from a networking side of things? Because they're kind of two ways of looking at that. I'll try and answer it before you come back. So again, Network Plus is a great foundation for that, because it's cross-vendor. Very good. So again, so Network and Security Plus are the two kind of mainstays. That would give you great foundation, but not. I'm not talking about beginner level here. Certainly from a point of view of sort of the startup SME side of things. And then it depends on what kind of house you're at. So if you're going to go down the Microsoft route, okay, so you're looking at it from a networking side of things, come in and take a look at some of the Microsoft professional courses. So supporting your servers and clients. Nearly 85% of networks are run by Microsoft anyway. And those are also very good sort of foundation level, but take you to a level which is at an accredited level with Microsoft. So even though they're foundation, they give you a good set of letters after your name as well. Okay, so they actually mean something to Microsoft as well. So if you're still into Microsoft points and partnerships and things like that, that's true. And then from the other side of things, purely from the networking side of things, is Cisco all the way, CCNA.
Brilliant. A quick question. How do you see the future of network security progressing, especially in today's climate?
Well, again, that's one of those. It's a great question. Has that come from you?
Come from me.
Yes. You should give me a list of these before you ask them.
Sorry.
That's a really great. It's a really great question, and it's something that we discover on some of the courses. In fact, we do. So when we're doing, especially when we're looking at the analysis side of things, where we're putting into place the threat analysis side of things and looking to the future, we actually layer this into some of the apprenticeship courses that we do. And in fact, some of those courses I've just mentioned, Security Plus and the CND, it's now part of that, where we're actually doing future predictions. And so what we do is sort of near real time. That could be anything between 6 months to 12 months, and then up to sort of 2 years, and then a 5-year prognosis of what potentially could happen. Now, for those of us that work in IT, the next 5 minutes changes. And so to actually try and predict where the threat and where security is actually going to go from a cyber side of things within the next 6 to 12 months is almost impossible to to faction in kind of thing. There are loads of different ways that you can analyze it and do that kind of thing. And again, my protect officers on here will probably be nodding at me in the fact that they really, when they pitch up for work in the morning, they never really know what is going to actually land on their doorstep with the type of different type of attack, I suppose, that comes into place. But they all come from a foundation. So if we're all talking about denial of service or SQL injection or some kind of online fraud, cyber fraud kind of thing, they all have a baseline, I suppose, really of methodologies, and none of that is really going to go away, I don't suppose, in the near future, I would suggest. But as technologies change, of course, so do the threats. So things like, if you think about where we were at for the IoT, for example, so how unsmart were our homes 5 years ago as to how they are now with the amount of devices that we've got where you can talk to something that turns your lights on and changes your music and does all of that kind of thing. Well, people forget the fact that that, of course, is using internet resources, which are using default security and default ports. And in fact, it's something that I deliver to our police officers, in fact, when they come to us at WIBO, is how to use Alexa to turn off a CCTV system from outside of the classroom. So we're actually outside of the classroom hacking in and turning off CCTV and security cameras and things like that from outside someone's home. So the answer to your question is I don't know, Phoebe, I suppose, really, but it is something that we kind of factor in, and it's all part of that threat analysis and the security side of things.
That makes sense.
No, Ralph, I can see your question. Oh, sorry, I've jumped ahead, Phoebe, sorry.
That's all right. Please go ahead.
So Ralph has put, does antivirus really or actually reliably 100% protect your devices? No, is the answer to that. Unfortunately not. So your antivirus, nothing is 100% anyway. So that, that's carte blanche. When it comes to antivirus, they're only as good as the signature definitions that they have. So they will update invariably every time that they run a scan, or they may update sort of once every 24 hours. But they update against an online catalog, which is held by whoever is providing your antivirus with you. So, for example, if it's Norton or or Sophos, McAfee, it doesn't matter. They're all great. But of course, they only get their signature definitions from the threat sensors that they have out on the internet, collecting the information from the threats that they are seeing. The attacker, as I've kind of alluded to, the people that are scripting this are always one step in front of that database. Your database invariably is 2 steps behind the database that Sophos has got. So you are never going to be 100% up to date, or therefore 100% reliable against any of those kind of attacks. And then we have the unknown variables, which we call zero-day attacks, which take place against vulnerable systems, and nobody actually even knows that there's a vulnerability against it. So, and you can never, ever counter against that, unfortunately, either from a virus point of view or from a network defense side of things. A good question, great question.
Annette has also asked, how do you analyze and verify our network system by using several antivirus programs like Antivirus, Avast, including firewall security?
So there are, it's another great question. So there are software packages that you can put in that will do vulnerability scanning and analysis for you. Nessus, for example, looks at those kind of vulnerabilities and things like that. Microsoft have got a very small one, which is called the MBSA, which always comes up, and it's still widely used, invariably, even though it is a little bit sort of nuts and bolts these days. But invariably, what you're doing here is you're auditing. The best way that you are going to audit this is by using a certified ethical hacker and doing a penetration test, either internally or externally. Okay, that's invariably what larger businesses will have, either an internal team that do this, and invariably they will also be exercising with red and blue and purple teaming and things like that. But the way that you're fundamentally going to do that is through a penetration test. For everything that you've listed in your list, Annette, I would suggest that's the solution that you're potentially looking for.
So we've got 4 more minutes. If anyone else has a final question to offer, any other further questions will be saved on the chat anyway, and we can respond to those as well. You can also email us at sprint@firebrandtraining.com for any queries. And yeah, just thank you so much for joining us, everyone. Wishes for a lovely weekend. Thank you, Phil.
Thank you very much. Thanks, guys. Thank you very much. Across the world.
Across the world, indeed. Yeah, we'll leave the chat open for a couple more minutes. But otherwise, have a great weekend, everybody.
Perfect. Yeah. Great weekend, everybody. Stay safe.
Stay safe.
And greetings back to Berlin as well, one of my favorite cities. Greetings to Cossington as well, one of my favorite villages. I actually spent 3 years in Berlin. I was stationed in Berlin in the late 80s, early 90s. I was on the Berlin Wall the day it came down, in fact, so that ages me a little bit, doesn't it? But that's my claim to fame. And Nuremberg is a place I know as well. So I used to train close to Nuremberg at a place called Vilseck, out on the border with the American military as well. Beautiful place. And Bladford Forum, fantastic. I know it well. Dorset, beautiful. It's like Phil's Whistle Stop Tour. I'm almost like a tourist guide now, aren't I?
And you're in France now, aren't you?
I'm in France now, yeah.
Yeah.
Annette, I'll look you up. It's when it's safe to travel for a beer festival, I'll give you a nudge.
Okay, brilliant. On that note, it's about to be 1 o'clock here in London, in the UK. Again, thank you, Phil, for today. Brilliant session. I actually made a mistake. Next session with Phil is actually on the 20th of November, not the 30th. But please have a look at our homepage. He'll also be around early next year as well. So we're really excited. Thank you all. Have a lovely weekend. And yeah, maybe see you next Friday again for our next sprint.
Fantastic. Find me on LinkedIn. Look for me on LinkedIn.